welcome to Azure Serverless Conference.
Welcome to Azure Serverless Conf.
Welcome to Azure Serverless Conf.
My favorite part about serverless technology is that it's so easy to get started.
My favorite part of serverless technologies is the ability to be productive without having to worry about all the underlying bits and pieces.
My favorite part about serverless technology is that I can get started super quickly and I only pay for what I use.
Just let me write my code, build my integrations, spin up databases, and Azure, you take care of the rest.
My favorite thing about serverless technologies is no infrastructure maintenance.
You don't have to think about compute or storage. You just get started and start building your apps.
I am looking forward to connecting and engaging with our community and all of the viewers that join us today.
I'm looking forward to hearing from people all around the globe about what they're doing with serverless and seeing what I can learn and make my applications even better.
Over the next 20 hours, we will have some fantastic live sessions showcasing many of the serverless technologies available in Azure, as well as a host of sessions you can watch on demand.
Enjoy the event.
Enjoy the event.
Enjoy Azure Serverless Conf.
Hello, hello, hello. Welcome everyone to our very first Azure Serverless Conference. My name is Nithya Narasimhan, and I'm a senior cloud advocate on the developer relations team at Microsoft. And joining me from our amazing MVP and RD community is Melody. Hi, Melody. How are you doing today?
I'm great. So excited to be here.
I know. I'm joining from New York, and Melody, you're joining from?
British Columbia, Canada.
Woohoo! So take a minute, tell us in the chat where you're dialing in from. We'd love to see you from all over the world. So let's first talk a little bit about what we have in store for you today. Azure Serverless Conference was actually organized as a stage for the Azure developer communities, for both the community and industry experts to share what they've been doing with serverless in their applications. So we're going to talk about things like Azure Functions, Cosmos DB, Azure SQL, even got a battle royale between Logic Apps and Power Automate.
I can
Over the
hardly
next
wait.
20 hours, you're going to see and hear from community members all around the globe. They've built amazing services. But first, how are we going to start this off, Melody?
Well, the Azure Serverless conference is 3 hours. I'm so excited. 3 hours of live streaming, as well as an entire track of on-demand sessions. They're available now at aka.ms Azure Serverless Conf. I'll pop that into the chat for you to make it a little easier to find. Each of the 3 live streams will have its own unique content delivered by members of our Azure community. Such a great community that we have. If you miss any of these live stream sessions, no worries. All the sessions will be available on demand shortly after each session concludes. Each of the live sessions will have live Q&A with each of the speakers. If you'd like to ask questions, we'll be sure to join the live stream on Learn TV and submit questions in the chat. So what do we have going on today, Nydia?
Wow, where do I even start? I'm going to let you talk about the keynote, but I think we have a number of speakers. We're going to have talks on media processing workflows, a battle royale, as I mentioned, between Logic Apps and Power Automate. We're going to have an amazing session on how you can use serverless gaming, large-scale gaming. We have people talking about Cosmos DB and Azure SQL usage, and a lot more. But we're kicking this off with an amazing keynote, if I'm not mistaken, right?
Yeah, thanks for that great overview. I'm so excited. There's so much great things going on today, and I'm super excited about the first session of the day, the keynote, how the .NET community team uses serverless to automate all things. With John Galloway and James Montenegro, let's take a watch.
Hey everyone, how's it going?
Oh, it's going wonderful.
Awesome.
Where are you both calling in from? I was always curious.
Yeah, we're super excited to be here and to kick off all the things. So we're ready when you're ready.
Let's do this.
Over to you guys.
Thank you. See if we can bring up our slides. Boop. Awesome. Well, I'm James Montemagno, like Melody said.
I'm John Galloway.
And we're on the .NET community team. And John did come up with that absolutely astonishing title. But John, it just didn't fit on the slide. I'm not going to lie about it.
I thought we got paid by the word.
Yeah.
That's
we do not. So we're going to show you how our team automates all of the things so we can do more things and then automate more things. So you might be wondering, well, who is the .NET community team? And I'm so glad that all of you asked. It is John and I, but we also have amazing team members from all around the globe that are out. And our mission, actually, from our OKRs, are to enable, grow, and nurture a diverse and inclusive .NET community to where actually every single individual feels warm and welcome and have the ability to learn how to build amazing applications with .NET. And of course, you can build serverless stuff with .NET, which is absolutely awesome. So you're saying, okay, like, what does actually a .NET community team do? That's a great mission statement, but what do we do? Well, we do a lot of things. We actually help build and maintain not only the .NET website, where millions of people go every single month to learn about .NET, but also interactive pieces like .NET Live TV that we'll talk about today. We help produce awesome content from Microsoft Learn, so anyone can learn for free how to build applications with .NET. We help support the amazing user groups and community members around the globe. We present at conferences just like this and also put on conferences like the upcoming .NET Conf at .NETconf.net, which is happening in November, so make sure to check that out. We also do workshops and provide workshops for the community. We provide architecture guidance. We help with the MVP program, and we help do the blogs. And this is just like 8 of the things that we do. We do like so much awesome stuff, and we love it because we love .NET and we love the community.
Yeah, like James is saying, we just have a blast doing all kinds of stuff. Some of the things I've worked on recently are like the .NET Conf, helping organize that, contributing things to the .NET website, just had some features launched last night. We help run live streaming shows, so much more. And, you know, while we do have an amazing group of 6 people, we just can't do all that manually. There's just too much to organize and handle and set up. And, you know, we want to solve that by using .NET code. We don't want to write just a ton of extra .NET code, because then we'd have to write, debug, maintain, figure out why it didn't run on a leap year, all that stuff. So we really want to be strategic about what we do. So we have built an army of a serverless army powered by .NET. So, a great example of this is the .NET website. It gets tens of millions of views in a month, and it's built completely on .NET technologies. On the front end, we've got ASP.NET Razor Pages and Blazor. Blazor is using WebAssembly. We've got Azure Search. Behind the scenes, we've got a ton of backend services. And one of the newest community projects we've launched is .NET Live TV. You can think of it as just like live news for .NET developers. It's got live streams and events, things going on all the time, and it's live chats with us and with the programming and engineering teams.
Yeah, it has like a really interesting backstory too.
It does, yeah. So this started way back when .NET Core was first launching, like 2014, 2015 timeframe. And we started just doing these Google Hangouts calls. It was Scott Hanselman, Damian Edwards, and myself. And it was just random Google Hangouts, and we'd chat it and throw it out on Twitter and see who showed up. And after a while, Damian put together a website. This is some of the first stuff that prototyped Razor Pages. And it was a really cool website, but there was still a lot of manual work. If you didn't set things up just right, if you didn't name them just right, the show wouldn't work. It was a catastrophe. And it took tons of manually updating. And also, it was very, very specific to ASP.NET Community Stand-Up. It was one show.
Yeah, and before I was John's manager, I was super jealous of everything that John was doing with the ASP.NET Community Stand-Up. I worked on the Xamarin team, and I basically just wanted to copy everything that John was doing. I was like, this is amazing. And I actually set up a call with John, and I said, I want to steal all your code and do all the things. And then we said, hey, you know what? Like, why don't we just do this, but for everything, right? Because .NET truly is your platform to build anything, not just web apps, not just mobile applications, but truly anything. So we went off and we talked to all the PMs and engineers, and we said, why don't we set up community stand-ups for all of the shows? Granted, we didn't have the infrastructure, really know how to build this thing, but like we could do it. I've never built a website, but John has. So we could totally build this, right? So funnily enough, we got on Twitch and we started live streaming for about 6 weeks, just one day a week. And we built an entire .NET community stand-up, completely open source web page. It pulled from a single YouTube playlist as the source of truth. It had a countdown timer, and it parsed all the show information into different categories and all this stuff. We're feeling real good. We have people in the studio in channel 9, and we're just like, wow, this is awesome. And then COVID hit. And then we're like, well, we got stand-ups. We got to figure out what we want to do. And all of a sudden, all of the team members from other teams said, we love what you're doing, but we want our own shows. We want to do more shows. We want to engage with the community more. So we said, let's just go crazy with this thing, not just have a .NET community stand-up with a bunch of different shows. Let's build .NET Live TV that at this point has 8 different shows, and we're streaming 10 times a week on the .NET YouTube, Twitch, and Learn TV. So we said, well, how are we going to build this thing, right? I haven't built a real production application in a while. So let's go into the requirements mode. Well, what do we need this thing to do? Well, we actually need to normalize the data into a single API. YouTube is one source of data where we schedule shows, but we also schedule shows on Twitch and on Learn TV and other places, and want to highlight other community members. So let's sort of be able to update that schedule from not only YouTube, but also blob storage. We want upcoming shows and completed shows. We want a live show view, kind of, so we know if something is streaming right now so we can display information. We, of course, need to easily be able to scale this thing. What if right now we have 10 shows, but we have 20 shows next week? Everyone wants to start live streaming. We want to be able to add those things easily. And of course, we want to get metrics. We want to see how our shows are doing, how many comments, how the engagement is going. And of course, generate those sweet, sweet reports for all of our bosses.
Yeah, so the first part is to create a backend for this website. So what it does, it's an Azure function. It's running with with .NET, and it's pinging against some backend data sources. It's got a YouTube API, and it's also got JSON files. And YouTube API rate limits us. So by setting this up in a function, we're able to kind of consolidate that and minimize our calls over to that. And then that shares that information over to Azure Search. Azure Search is already being used by the .NET website, so this was a really easy integration to do there. Then when we want to surface this on the website, we needed kind of a backend API. And fortunately, that was really easy to set up with that backend infrastructure. So we've got a Blazor WebAssembly front end, and then it calls into a REST API powered by Azure Functions with .NET. And then that calls into the Azure search and gets us a JSON blob of data. What's really cool with that is the front end has to do almost no work. It just gets this pre-digested, perfectly set up information and just displays it. So no matter how much traffic the front end gets, it really scales well. And once we've got that information, it lights up all this cool stuff on the front end. So we've got one API endpoint that tells us when there's a live show, and it'll automatically flash at the top of the website. And then once you're there, we want you to see our other shows. And so this lights up. Again, we've got this thing that says, here's all our different shows you can see. And then we want to make it easy to find our upcoming and recently completed shows. And so that's all right there as well.
Yeah, it's really cool that, we started with one function, but it scales out that we create like 10 different functions to all do different little pieces of functionality, both publicly available and some admin functionality too. And then on top of that, right, we have the website. And then the important part is to get all the analytics and all that data. So the analytics is actually really interesting because, we're streaming to a bunch of different places, which means we need to integrate into all of the different data sources. So we actually use Power Automate here. And there is a battle royale later, and we use both Power Automate and Logic Apps, which is fun based on the purpose. But we have Power Automation that is scheduled basically every night. And what it does is it pings a bunch of different services and normalizes the data. So the first thing it does, we have yet another Azure function powered by C# and .NET that calls into the YouTube API. And what that will do is get all of the on-demand views and all the chats and all the likes and all the comments, and it shoves that into a Cosmos DB database, normalizing the data. So updates, deletes, and reads and all this stuff. We also have some Excel spreadsheets for live, information that's coming in on the shows. So it's just like another piece of data source because everybody loves Excel. So we have some data there, and it normalizes that data into the Cosmos. And then we also have internal data sources, and we use Custo queries in that Power Automation. And then again, we shove that into the Cosmos DB database and then generate a beautiful, wonderful Power BI dashboard that we can send to all of our bosses. And this is actually what it looks like. This is one of ours. As you can see, I'm a Power BI expert. And as I shake my head, no, you can't see me. Thanks, Lamont, for hiding my face. I can't do it. There you go, shaking my head. I'm not. But, to me, I was able to take all that data, generate it all here, and see how our shows are doing over time. And of course, all this data is public data, right? You could go to every single Twitch, every single YouTube, and actually look up this data. But if you're one of our 20, 30 hosts, you don't want to do that. You want to go to one place that's here. And while we do have this beautiful Power BI dashboard, you got to go load up Power BI, go do this thing. So we said, let's automate and make it even easier to give direct feedback to all of the show hosts. So we created weekly reports. This is cool because we're reusing all this data and all this intelligence. And we have yet another Power Automation every week that runs, pings that Cosmos DB database, normalizes and figures out the last 2 weeks of show data, and sends a team message and an email every single week to all of the live streamers. That's really cool. And this is what that looks like. This is actually a screenshot from our Teams channel where anyone can come in and see the data and, of course, go into the Power BI for more information.
Yeah, and so this was one of our first ones, and it worked really well for us. And once we had kind of the code and the patterns down for this, we started seeing opportunities all over the place. So one that popped up recently is this .NET events. And, the .NET website, now that we had live shows on it, was starting to become a very dynamic community place to hang out. And so we thought it was really natural to make it easy to find events that were going on around the globe as well. So, first of all, we thought, well, we'll need to create our own API. And it turned out there already were some data sources internal at Microsoft where we were tracking, hey, who's going to this conference and which conferences are we sponsor? But they were for all conferences, not just .NET. So we needed to filter and normalize that data a bit. And then we also wanted to be able to call out some featured events at the top of the screen, things like .NET Conf that are really important. We want to make sure that we were able to feature those as well. And then we didn't want to be doing all this every time you hit our website. So we wanted to have a data cache that would keep all that information. So here's how we went about doing that. First of all, we dusted off our code for our Azure Functions. However, this time I decided to use an Azure Function using .NET 5 in isolated mode. One of the reasons for that was that it made it really easy to integrate with SQL Server. And so I'm able to use SQL Server with Entity Framework and connect directly across. For our featured events, we're using a JSON blob that's just over in a GitHub repo. And the reason for this is it makes it very easy for team members to submit a pull request and update it there. And then this goes through and gets all that information and then puts it in a JSON blob using that pattern again.
Yeah, we love this pattern if you can't tell. So it's one thing you'll see over and over again. But I think this is really cool because this isolated mode, John, this thing is amazing.
Oh, it's crazy. So some of the things that I just love doing with this isolated mode is I was able to use all my ASP.NET Core skills. So I could use ASP.NET Core configuration. I could use user secrets, which are awesome. So that uses a JSON file on my local disk, but it's not in the source code directory. And so I can't accidentally check it into GitHub. Hands up if you've ever done that. And then also it can overlay that when I put that up in production, and those user secrets are then overwritten by environment variables in Azure. And then hooking up any framework is super easy. It's like the 2 lines of code that I've written a million times, and I just do that again. So here's the actual function. This is the thing that runs on a schedule and goes and gets those upcoming events. And I can, you'll see the token replacement there, update events timer, and that's able to read directly from the, my local settings on my computer and then the Azure settings in production. And then here's kind of the workhorse function that runs the, it's the brains of the function here. And we've got it separated into a separate function so it can be pinged via a REST call or run on a timer. So you'll see up at the top, I've got an EF query, and it's got a link filter to make sure that we're only getting those .NET events and the ones we're ready to put up on the website. And then after we've got that, super easy to just process it. So we serialize it to a JSON blob and save it off to storage. Again, using that pattern James and I have been talking about where we have that JSON cache. So for instance, if we're unable to hit the database, it doesn't matter. We can still respond with the information. And then we also at the bottom quickly run over, grab that JSON blob from the GitHub repo and also store that information. So then when it's time to retrieve data, we have a very simple ASP.NET Core is able to call into an HTTP endpoint exposed by that .NET 5 REST API. And then it grabs the JSON data and just exposes it over. One really cool thing that I was able to do as part of this is there's a new feature that they had just enabled for this, which is open API generation. So this will generate a Swagger document that is great for documentation, for sharing it with clients and with other developers, which I did. I sent them, here's a link to our Swagger. And you'll see it's just a few attributes that I had to set up at the top of the page. And it automatically, like I tell it, this is the body type, and it's able to generate the Swagger from that. And a really cool also thing that I get out of this is a Swagger page. So it actually generates this documentation. Like I said, I was able to send it over to a team and say, this is the API we need to support. And these Swagger pages also, when you click on a specific function, it will show you all the different things, and you can actually click on links to try it out and test it. So the end result is this page. And what's really magical about this is we don't have to do any work. It's automatically maintained. You'll see those 2 call out events up at the top of the page. Those are maintained by just putting some information in a JSON blob over in GitHub, and it all just works.
Yeah, I think this is really, really cool because as you see in the back end, we can use sort of that standard ASP.NET logic that we know and love. But also like Azure Functions hides all of that authentication. It hides all that configuration you need because you can put all of your connection strings, your username, your password, any of that information into the environment variables, right? Mm-hmm. So none of that stuff is checked into source code or anything like that or hard coded. It's all environment variables. So we can easily pivot back and forth. Like we said earlier, the .NET website is ginormous and it's many, many pieces of technologies. So we wanted to make sure that if we're having an event and marketing sends hundreds of thousands of people to live TV or to the events page, that the rest of the website stays up and it's ready and good to go. So these are all deployed into different resource groups in the back end, and they can all communicate with each other. So if one part of the website's getting, clobbered with information, everything stays up and it's ready to go. So I absolutely love this architecture on there. Really simplifies development all up, especially when you're building at scale. Now, we've talked a lot about like some of the .NET website pieces with .NET Live TV and the events page, but I also wanted to talk about our blogging system, because this is actually a really interesting problem to solve, which is like how blog articles get onto the blog. And now, John, I know what you're saying, like, all right, you probably just log into a CMS, you write some blog post and you get it like done, right? No. Because we're engineers, it can't be that simple, and that's not allowed. So the problem is, it's like tons of people are blogging all the time on the .NET blog from the team. And we wanted to create sort of an engineering system for the blog. So I worked with Emo Landworth and Jamie Singleton from my team. And we said, well, how do we make blogging easier for anybody? Well, we think about this. Like, well, what does that mean? We want easy authoring experience. We don't have to have people log into a system, write a bunch of HTML or different things. We want them to write in a language they feel familiar with when it comes to blogging. And usually we want sort of the review process to be easy. If you've ever used a CMS, you can't like leave comments. You can't do suggestions, right? We're engineers. We want to do the things that we're doing in GitHub or on DevOps or wherever we're coding at.
And this is a big deal with these .NET blogs. Some of these get hundreds of review comments.
Yeah.
So we really need a good review system.
And a lot of times these blogs are scheduled, a month ahead of time. So we want that long process, anyone involved to do it. And of course, we want to make sure that, blogs are scheduled correctly on the calendar. And of course, got to have sweet reports. So this is the actual authoring experience that we use internally for the .NET blog, is we use GitHub. It is our one source for all things blogs. And it's easy. Every single .NET team member has access to the .NET blog repo, and they just write a markdown file. Like, you just write markdown because that's how we code, right? We write markdown to document things. That is how you blog. And then you make a pull request, and that's it. You make a pull request and the review process starts. There's a bunch of automation there with actually GitHub Actions runs a bunch of .NET code, and that actually validates all the blog entries. And I'll show some of that code here in a second. And then when the blog is validated and ready to go, it actually hits a logic app and sends it information to start the scheduling process. What's really cool is that Emo actually wrote a .NET command line tool that can run anywhere to help streamline this process. So anyone goes in, they clone the repo, and they just say new post, which runs a .NET service and then script, and you just enter information. What's the name of the post? What do you want the slug to be? When's the publication date? And select your categories, and it scaffolds it out for you. Then you just write the blog post. And here's actually Stephen Tobe's amazing blog post on .NET 6 performance improvements. And it's Markdown, right? You just write Markdown, you do the thing, and he created a pull request with it. And you can see there's 119 conversation pieces on this single blog post because it's ginormous. It's amazing if you haven't read it. It's absolutely astonishing. And when that PR starts and when it's merged, there's this validation flow that happens. So we have a planner workflow that happens that calls the logic app, and a validator. And that validator is just a big .NET script that gets run in GitHub Actions. It's all automated, right? Which is really cool. So there's about 24 different rules that get automatically validated. Like, are images accessible? Are they the right size? Making sure that any language specific URLs aren't in there. So if you're in Spain, it goes to the correct URL on documentation for you. So it's really nice. It's all automated. Emo wrote that. He's amazing. And then once it's validated, it kicks off this logic app. And this logic app is in charge of putting things on our planner, which is like a Kanban board, but it has calendar integration too. And there's a lot of things that happen here when this logic app kicks off, because it needs to figure out and connect the GitHub pull request to a planner ID. It needs to make that connection. And it needs to figure out, well, do I need to create a task on the planner? Do I need to update a task on the planner? Do I need to delete a task on the planner? Do I need to merge it? So the GitHub action sends information about the pull request to the logic app. So it has a webhook and it's listening there for it. And what it does is it parses all this information and stores information about that connection between the planner task and the GitHub task in table storage. And then it does a bunch of operations on the planner. And this is what that looks like. Woo, look at that thing. It's beautiful. Oh, I just get shivers and joy whenever I see this Logic app that I wrote. I'm not a Logic app pro, but look at this thing. And it's so, okay, let me zoom in here. Let me show you what's actually happening here. The first thing is that there's a bunch of different ifs and compilations to figure out what it needs to do. So one of the things that may need to happen is a pull request may have been closed and not merged. And it goes down and it figures that out based on information passed in and if there's anything in table storage already. And if so, it deletes the tasks on the planner board and deletes the entry in table storage. Another possibility is that the thing has been merged and it's ready to go and it already exists. So move that planner ticket over to another bucket and then assign a task, that task to individuals to schedule it inside of our CMS. Other things is it could have just been an update. Maybe they changed the due date, maybe the title, that just updates it automatically. Else, if it's brand new, it will go through, create the task, add details, and then update the table storage automatically. So it creates this beautiful flow for what it's doing. And this is what it looks like. So here in the example of Steven's post, we see that a new entry has been added at the top of this blog draft in process. When it's merged, or if it's just been updated, it'll update these dates. But once it's merged, it moves it over to SEO review and it'll attach it to other individuals that need to review it. And then, of course, there's also this nice planner board so we can schedule out our blog posts automatically, which is really, really nice. Now, once the blog is up and running and good to go, we need reports. And there's a whole bunch of really cool things that happen here. Whenever a blog post is posted, and that ticket is closed on the planner, that kicks off a Power Automation hook that then updates our internal DevOps board for tracking. And we also sort of use the DevOps as sort of a database in a way, because every night we have a Power Automation that runs off, calls into our Custo service to get information about blog views, updates that ticket automatically on DevOps. And then we have another one that every week kicks off, another Power Automation, calls into a query into the Azure DevOps board and generates a Teams message and an email. And this is what that looks like. Again, very similar to our live stream stuff. And we see all the different blog posts they can click on and see their views, but I've hid them here because that's internal information. So we're there. And these are just 3 examples of things that we've automated that you get to, kind of see every single day on the .NET website and enjoy on the blog. But we automate all the things because we're ridiculous and we love it. So much that we love this automation that I can't help myself. I even automate our team stand-up because I don't think it's fair if you just go alphabetical every single week. So I have a Power Automate that calls into an Azure function that randomly sorts a bunch of names and things and posts information to our Teams channel. And to make sure that our stand-ups go super streamlined and no one talks about the weather, every morning I generate a weather report, fully automated, not only with the weather, the moon conditions, the precipitation percentage, and the air quality as well, which all call into different backends, which is really, really cool.
And, once you've got this, you can apply it to all kinds of things. We have these .NET Conf community events all over the world. Used to be in the past, there's a lot of manual work in order to review them and get them, make sure they're in the right date ranges and all that, and get them scheduled. Here, we've updated this so you fill in a Microsoft form and it automatically goes live. So here you submit the form, a function runs, it does some validation to make sure it's in the right date range, it checks for who to notify and all this stuff, and then it adds it to an Excel spreadsheet because, as James mentioned, we love Excel, puts it on a planner board for easy management by people that are helping with the events, and sends out notification emails. And then we need to geolocate to put them on the map. And so the way we do this, a function runs, it hits the Bing Maps API for geolocation and stores that information. This is important because we're rate limited on that Bing Maps API, so we're not hitting it unnecessarily. Then for the website to display it, super easy. .NET Function exposes an HTTP endpoint and returns JSON to an ASP.NET web page.
That's right. I mean, I literally love this stuff so much that once I got into it, I said, what else can I make serverless? At the beginning of the pandemic, I got super into Animal Crossing on my Nintendo Switch, and I needed to figure out how to share my turnip prices with all my friends. So I created a completely serverless application called Island Tracker on the App Store. It's free. If you're into Animal Crossing. And what this does is every single API, the authentication, the backend, the updates, everything is 100% Azure Functions, uses table storage on the backend to figure out all of the user accounts and information, 100% written in C# with .NET, including the mobile applications, all written with Xamarin Forms. So truly, you can build absolutely anything, and you can go off and build an awesome serverless army powered by these amazing services and .NET. If you want to learn more, go to .NET for all the .NET goodness, including all of this amazing stuff that you saw here today. And thanks for watching. Have a great Azure Serverless Conf.
That was fabulous, guys. That was so exciting.
It's a lot of fun. Yeah.
I was
really did
I
automate
think
everything.
We had there was a lot of engagement. We had a couple of questions. I think we have time to take one. So one of the questions was, for real-time API calls, are you using Azure Functions? What about cold starts? Yes. And using premium plans, maybe.
Yeah, it's a great question. For the most part, it's not really a problem, partly because we also cache our services on the front end. So we allow enough time. But usually these functions are so lightweight, they're doing so little work because they're using this kind of pre-built JSON blob, system that they can return that information very quickly. So, but because the website or the consumer is caching that information and we've got long enough timeouts, it hasn't been a problem.
I think if we have time, there was one other question which says, do you have a documentation blog instructing you how to use service principal to access block storage? I think that's something you might be able to even answer on the chat. That's a long answer.
Yeah.
But short answer, yes.
I will say that one thing that reminds me of is we do almost no code in order to handle authentication, which we love doing, right? So we handle all that stuff using like Power Automate, and we just pre-authenticate with our services, and then we don't have to write code to handle that stuff.
Yeah. And that's the beautiful part too, is to the point of using Logic Apps and Power Automate is I'm already signed in. I'm already authenticated with Azure or with Power Automate, which means when I'm connecting to Cosmos DB, or I'm connecting to Excel spreadsheet, or I'm connecting to Teams, I'm already logged in. I literally don't write any code to do that, and it knows everything about me. That's one of my favorite parts about using that type of automation when you're integrating with so many different systems. Like, could I go and read an Excel spreadsheet and parse it myself? No, I just I could, but I'm just going to let Power Automate and Logic Apps do it for me, which I think is absolutely lovely.
What? You all made me want to come and follow your Twitch channel now, because honestly, I'm not even kidding. This was the most amazing keynote talk ever. I'm going to write this whole thing down. I find so many reusable design patterns. I hope you can stick around and on the chat and answer a bunch of questions. But I think, Melody, we need to kind of move on and show the interstitial video now. But thank you so much for an amazing keynote. Should we do that?
Yeah, I think that would be great.
Awesome. We're going to talk Azure Functions. Let's get the quick review of what that means.
Up until now, the problem with building applications has been that before you could even start, you had to choose a framework, learn how to deploy that framework onto servers, then manage and maintain those servers over time. Not exactly easy, quick, or efficient. Thankfully now there's Azure Functions, the easy way to build the applications you need using simple serverless functions that scale automatically to meet demand. No worrying about infrastructure or provisioning servers. Whether you're new to development or a seasoned pro, within a few minutes, Azure Functions helps you create applications that accept HTTP requests for a website, processes product orders via queue messages, react to data flowing from devices like an IoT hub, or just run simple scheduled tasks. And since Azure Functions scales automatically, all you need to do is write your function logic. Azure Functions handles the rest. What's more, you only pay for what you use. With Azure Functions, you'll write less code, manage less infrastructure, and have a lot less upfront costs. See for yourself at functions.azure.com and try it, free. You'll see that making applications has never been easier with Azure Functions.
Well, that was really good.
How to read all the things.
Yeah, I know. Between that keynote of automation and then now with the Azure Functions, I really think we're ready to move on to the next segment of media processing workflow with Azure Serverless with Braden and Jason. Are you guys ready?
Yeah, absolutely.
Yep.
All right. Well, we'll get started. Hi, my name is Braden Riggs. I'm part of the developer relations team here at Dolby Io.
Hi, and Nancy, I lead that team.
Yeah, Jason is being really modest. He's been a mentor and has really helped me through this project from the beginning, and he's kind of here to help answer questions while I present. So before we get started, if anybody does have some questions, please post them in the chat as we go along with what your use case is, and when we get to the end, or maybe a little bit during the presentation, we can chat about them. So before we dive into serverless media workflows, let's quickly speak about what Dolby Io is. So Dolby Io is a self-service platform that provides a number of APIs that allow developers to build communications, media, and streaming solutions for things like podcasting and telehealth. The APIs come in two flavors: are communications APIs, which focus on real-time streaming and communication technology. So think like building your own live streaming platform. And our media processing technology, which offers solutions such as music mastering, audio analysis, or audio corrections and enhancement. Dolby Io is really just taking the signal processing technology that Dolby itself has been using in cinemas and music studios and packing it up in a way that allows developers to deliver it in their products. So why are we Dolby Io here, and why are we talking about serverless technology? As I mentioned, the Dolby Io team have been developing a series of media processing APIs, some of which can be used for data generation tasks, for things like speaker diarization, number of talkers, quality scoring by talker, and things like that. I've been working on this project where I take these large collections of sports podcast recordings, and I use these generation tools to create sets of data, which can generate insight into the macro trends relating to podcast creation. So we take these podcasts, analyze them with our media tools, and aggregate the results into data sets that we can use to explore these trends in podcast production. Now, this project started locally, but as I'm sure you can guess, the storage and processing requirements quickly ballooned to a size that was just no longer appropriate for local development. Additionally, our APIs generate insights specifically from the signals in the audio, and hence we don't create transcriptions of the spoken words. For this project, I was interested in also exploring the relationships between spoken words and sports podcasts, and hence I wanted to create transcriptions of the audio data. And as this project grew in scope, I began looking at cloud environments where I could scale up this project to align with my goals. And this is what got me started with Azure Serverless and developing media processing workflows. So to get a little bit more specific, what were my goals for this workflow and what did I need to do? Well, first, the workflow needed to have a filter of some sort to distinguish quality audio from poor audio. And this is because in sports podcasts, especially in the sports podcasting space, these things can vary wildly in quality, especially when shows have several guest speakers, each calling in from a phone or using microphones of varying quality. It doesn't make a ton of sense to transcribe low quality audio, as the results will likely be inconsistent and noisy. So the first requirement for my media workflow was to create a filter that can ensure we were putting transcription to good use. Media designated to be quality would be transcribed and added to our data set. Secondly, we want to keep the low quality audio and clean it up using some noise reduction tools. This is so we can take the designated low quality audio and manually explore some options to trim out the bad sections or review it for quality checks. Third and finally, I want this whole process to take place on the cloud in a ditch effort to save my poor computer from having to store all of this media and process the output transcriptions. Now, of course, I'm here today because we were able to accomplish this whole process, leveraging the power of Azure Serverless technology. In fact, as we're going to show, we didn't need to set up like a virtual machine. We were able to create this tool that can do either one job a month or scale to handle thousands of jobs a day without us really having to change anything at all, and at a really reasonable price. So before I talk about what the serverless process looks like, let's discuss a few of the individual tools that we use to help accomplish these tasks we outlined. So to solve the first challenge, we can leverage a Dolby Io API called Diagnose. Our Diagnose API is a tool that can perform lightweight analysis on media for a quick evaluation of the quality of the audio, along with other metrics and metadata. This allows us to route media through the Dolby Io servers to return a quality score for the audio, which we can then use to filter the media into a transcription group and like a correction group. So what does implementing a tool like this look like? Well, in Python, using the Dolby Io Diagnose REST API, it's pretty easy. We start by formatting a header with our Dolby Io Media API key, which you get when you make an account. And we also include the URL that directs the request to the appropriate Dolby Io server, in this case, our Diagnose server. Next, we format a body. And for this stage, we provide a URL that points to the location of our media that we want to diagnose. So in this case, that URL is our pre-signed URL for our Azure media storage. Finally, we post this request. If everything's formatted correctly, you receive a job ID. And after waiting a few seconds to a few minutes, depending on the size of the media, we can use this job ID to get returned results relating to specific audio problems, such as speech, sibilance, and silent channels, as well as a quality score, which is pictured on screen, that we can use in our workflow to decide whether we want to proceed with a transcription. Now, the audio score is on a scale of 1 to 10, where 1 is poor audio recorded on a low quality mic, and 10 is excellent audio quality, likely professionally produced. So in this example, 6 is pretty average, not good, but average. However, if we're spending the computational power to transcribe audio, we want to be accurate, and hence we don't want to transcribe anything with a quality less than 7. So it's worth noting that there's nothing special about this threshold of 7. It's just that in our testing, that seemed to work best for transcribing sports podcasts. If the audio quality scores below our set threshold, we instead need a tool to clean up the audio so we can experiment with alternatives to transcription. The Dolby Io Enhance API is excellent for this task, as it automatically reduces noise, levels speech, and corrects loudness, among other things. So much like the Diagnose API, the Enhance API is formatted in a similar way. In this case, we create a body, and the body includes an input and an out location. This is because Enhance outputs an enhanced file, as opposed to Diagnose, which just returns some data relating to media. So in this case, both the input and the output URLs are pre-signed Azure Blob Storage URLs. We also include a URL that points to the Dolby Io Media Enhancement API. We format this header in the same way as we did for Diagnose, and we post. In this case, we don't need to track a job ID because when it is done, we'll instead have an updated file on our container. So what exactly is this Enhance API doing? Well, here I have an example spectrogram of one of FDR's early speeches recorded in 1941. A spectrogram is a way of visualizing audio as a series of signal strengths over time. Now, if we take note of this particular segment here, and let me zoom in on it so it's a bit easier to see, we can see that in the enhanced audio, the spikes of signal are more distinct from the background. These spikes of signal are actually spoken words. So what the Enhance API has done is separated the signal from the noise. And this is useful for further experimentation where we can look to clean up the audio and maybe trim out some of the bad parts or even explore alternatives to transcription altogether. Our third tool that we use is the Azure Cognitive Services Speech-to-Text REST API. Once we've filtered our audio and are interested in getting a transcription, we can use this API to generate our text data. Speech-to-text works by formatting a header with our speech-to-text API key and by specifying the region-dependent server where we want to post this request to with the URL. We also format a body. And in this body, we specify some parameters such as the location of our file and the container we wish to output the file into. Then finally, we post this request and let the text-to-speech magic happen. So once the transcription is done, the results are output into a JSON file in the specified container. And in this case, we get a few different models for transcription, and we can pick one that works for our results. Okay, so those are our tools. Now, how do we put them all together in a function? So pictured on screen is a diagram of how all these pieces fit into a serverless function. We have our diagnose tool, which we use to distinguish quality audio from poor audio. We have our enhance tool, which we use to clean up the poor audio for further research. And we have our transcribe tool, which we use to generate a transcription of the media that has a diagnose score above that threshold of 7. Now, using these tools in isolation is one thing. However, part of this project is to create an environment that can scale to handle hundreds of jobs all asynchronously. Let's talk a bit about the few tools that we use to accomplish this serverless part. And then we can come back and have another look at the diagram. So for this project, we decided we want to wrap it all up in an Azure Serverless function. One part because we're already using Azure speech-to-text tool, and another part because the process to hello world, or rather getting started, was so quick and intuitive that I could just focus more on the complex parts of the project without stressing about building environments, etc. Specifically, we initialized this project in a Python environment and built the project using VS Code. Very quickly, I was able to create the environment I needed to instead accomplish this media workflow. So some of the tools that became especially handy were using triggers to handle the workflow. Now, there's two main triggers of specific interest in our use case. We have our HTTP trigger, which which would be perfect if we developed our project to work as a web app. And we have a blob trigger that could be used to function as like a cloud-based hot folder where every time I automatically place a file on there, it starts this whole media workflow automatically. So we then manage the job flow asynchronously using callbacks, which could trigger the HTTP trigger to move on to the next stage of the workflow, whether that be transcribing the audio or enhancing the audio. Great. So now we have all the tools we need to build the workflow. We use triggers and callbacks to help direct the workflow. And we use tools such as diagnose and speech to text to accomplish the goals of the workflow. Using serverless, we can wrap all these tools together into a single function, which can be triggered on a hot folder or on an HTTP trigger. This workflow could then be integrated into a web app if we want to make it a public tool. So you can see on screen we have our app in the bottom left corner. This app either triggers an HTTP request or uploads a file to an Azure hot folder. This event then triggers the serverless function, which begins the workflow by diagnosing the audio. As the diagnose completes, it triggers a callback, which brings us back around to the media workflow function. Using the diagnose audio quality score with the workflow function, it can either decide to enhance the low quality audio, which again triggers a callback on completion and signals that the job is done, or it will trigger the audio with the speech to text tool, which will then provide a notification of job completion upon transcription. All of this together constitutes the workflow, which can run asynchronously depending on how many files we want to pass through the workflow. So to recap, what does the serverless function accomplish? Well, for one, it provides a viable filter to help ensure we're getting the most bang for buck for our transcriptions. Two, it provides a path for our low quality audio to be cleaned. And we can review this low quality audio later with our audio engineers to see if there's a solution. And three, the whole media workflow is entirely serverless and asynchronous, meaning that we can run several jobs at once without having to worry about anything overlapping or interfering. So I'd say mission accomplished. But what did we learn from this project? Well, the first thing we learned is that media data is sneaky big data, in that the scale and size quickly sneaks up on you, and you have to be prepared to develop in an environment that can scale with the data. Two, we learned that callbacks and webhooks are critical to asynchronous processing, especially when you're working with REST APIs. By using webhooks, we don't have to leave our functions tied up in jobs when that stage of the job is being handled elsewhere. This also allows us to run multiple jobs asynchronously, letting the Azure serverless adjust resources accordingly. Third, triggers are your friend. I especially want to emphasize this point because picking the right trigger is critical to creating a tool that you want to use and that works for your circumstances. Great. So with all that said, I want to take this tool and share it with the serverless community so you can experiment and play with it. And we have a link to our GitHub here, which hopefully we can drop in chat. And we're also looking to add our project to the Azure Community Serverless Library. But if you follow me on Twitter or reach out via email, I'm happy to let you know when the tool has been approved so you can play with it yourself. And with that said, thank you to everybody who listened to my presentation. If you have any questions, I think me and Jason still have a few minutes left on the clock. Otherwise, please feel free to reach out to us on Twitter. Yeah.
Absolutely. That's fabulous. That was a great session. I particularly liked how you were able to put a couple of those functions together and string them together. So when you did that, what did you find were some of the best benefits of that? And if you were to add something additional to that to improve it in the future, what do you think that would be?
Mm-hmm. Yeah, well, for the most part, our process is really bare bones right now. Like we're just taking this file, we're, filtering it into a transcription group and then into a repair group. And I think the biggest benefit of doing that on serverless, right, is this idea of scaling up. And especially with a project like this, where, we are handling like anywhere from maybe just a couple of podcasts to thousands of podcasts. It's just so nice to not really have to worry about hardware limitations or building these environments. Instead, we can just run it and have it scale accordingly on Azure's side. Now, if we want to build this out even more, I definitely would love to take the workflow and make it a little bit more advanced, implement things like transcoding tools so that we can handle multiple file formats, and also include some sort of apparatus that can then take our transcribed files and maybe put it onto a SQL database so that we can help have a really nice aggregated set of all of our data from the stuff that we're generating with our own APIs in terms of number of talkers to all the transcription stuff that we're able to get from using the Cognitive Services API.
That makes sense. One of the questions from our audience is, Mark asks, what kind of input-output locations are available?
Yeah. So in terms of input-output locations, for this project, we specifically focused on using Azure Blob Storage. However, Dolby Io does also handle something on their end where you can, integrated with our API, you can upload the file locally and it can kind of handle the input and the output of the file and then return it to locally. I don't know if Jason wants to add anything on that.
Yeah, our media processing engine is pretty flexible in that regard. And usually by being close to processing the data, you avoid any egress, transferring of so working directly with blob storage made a lot of sense in this project.
Okay. Pimonto wants to know, when will Logic's apps variables support getting variables from Key Vault like Azure Functions with a Key Vault URI?
To be honest, off the top of my head, I'm not sure if I fully understand the question. Variables supported getting variables from our...
Yeah, I was going to say that's probably a question for the Azure Functions team because they're asking, or the Logic Apps team. So we could put that in the chat and see. May not be specific to your use case unless you knew.
Okay.
Makes sense.
But I like the next question. Franco's asking, how do we apply your solution to, let's say, the Olympic Games? This I want to know because I think one of the amazing things I liked about the workflow is the ability to do localization or kind of just adapt that transcript and kind of have that be simultaneously with triggers, right? Like you can simultaneously get this in different Olympic Games, United Nations, both same thing. How would you do this? What are your ideas?
I mean, it's no coincidence that I was looking at sports podcasts this past year, and the Olympic Games were on. So assuming that you had either the recordings of the Olympic Games now that they're done, or some way of collecting them live, our tool that we've posted pretty much just can handle it as like a hot folder. So you drop it onto the Azure, into a particular Azure container, which you can set up yourself, and it can then just automatically take it through the whole workflow. You can set a threshold for, either generating a transcription or not generating a transcription. And it works. It works pretty seamlessly. You can even have a continuous stream in there if you mess around with it a little bit.
Yeah, and I think that's one of the reasons contributing it to the community library lets people have access to it for customization, right? Because it's really about orchestrating a bunch of these functions to perform some sort of outcome. And with the pace of content being created, there's a high demand, whether it's Olympics or anything, right? And also being able to turn the content around very quickly. There's lots of use cases for this type of workflow.
I don't know if there are any other questions, but I'll ask one if time permits, which is, can you do real time? So the use case that immediately came to mind is being able to recognize, bad words, things like that, and kind of bleep them out in the 5-second interval or whatever. But I see this as a great way to support community things so that you're removing harassment, you're removing that kind of stuff out of these streams. So is it possible to use these APIs in real time to do something like that?
If Jason wants to take that question.
Yeah, sure. So the demonstration here, these are file-based media processing approach. So it's not providing the real-time filter, but some of our communications APIs and things are more geared toward real-time use cases.
Mm-hmm. Yeah, so this specific example here is like media post-processing in terms of like you already have the media, then you can send it through. Would love to have the opportunity to expand the functionality to something maybe a little bit more real time, because I agree. I think that's a really interesting use case.
And that's one of the great things about making this community available too. So that's something that as a community, it can be expanded that way too.
So I think apparently I don't know if you can hang out and go to the chat and answer more questions. There are a few questions about throttling, tips and tricks to avoid problems with throttling, or have you encountered bottlenecks with throttling? A lot of interest in that. If you want to kind of give a quick response, but we'd love to have you hop on a chat and answer that too, if that's possible.
Yeah, absolutely. If you don't mind dropping a link to where the live chat is, I'd love to take a look, because a lot of these questions, I really would like the opportunity as well to follow up and maybe give a more detailed response, so I'm not using up everybody's time here.
Sounds good. I think we should probably be kind of talking about our next session now, right, Melody?
Yeah, I think it's time.
I'm super excited for this one because we've heard so much great stuff about serverless and functions. And now we're going to have Davide Mauri come and give us the serverless full stack kickstart. And I'm really excited to hear more about this. Davide.
Hello. Hi, everyone.
Hello.
For having me.
Very nice to see you here.
Yep.
We'll let you take the stage and look forward to your talk.
Yeah, sure. Let's go. Okay, cool. Let me share my screen and let's get started with the Kickstart. So I love the Keynote because it promised like a very easy, startup time. So that's exactly what I want to show you, how to create a full stack application using Azure Function and also static web apps. So let's get started. How it is, and so that's exactly the goal of the session. Create a web client. Well, I will not be writing HTML. I will be using already one available with HTML and Vue. That will be our front end, and then for the back end, we will be using Azure Static Web Apps plus Azure Function, since they are so good together. We will be using .NET Core as a language, but we could have used Node or Python or any other language that we like. And we are going to use Azure SQL, specifically the serverless version, to be completely serverless. And that's what we are going to do. Basically, take the To-Do MVC app frontend that I like so much because it shows how you can create a frontend with a lot of different web client or web framework as you wish. I will choose Vue because that's what I'm passionate about. And then that frontend will actually work already by itself, but then we want to save the data somewhere else other than the local storage that where the data is saved in the sample. So for example, we need to have a database and a backend providing some REST API behind the scene that will nicely receive the JSON sent from the front end to the back end so that we can do whatever we need, like store the data somewhere. And that's exactly what we are going to do, right? So use this simple and super nice application. Simple, so also great for who is starting to learn coding or to be in this field, but very complete because it will give you a full end-to-end experience. And this is exactly the architecture of what we are going to do. So the client UI will actually send some JSON to the backend. And as a developer, I would love to be able to send JSON also to my database. And this is exactly what we'll be doing, even with Azure SQL, even if it's a relational database. It has been extended and it has evolved over the last year to be able to manage JSON, documents, graph models, geospatial data, all the data you can imagine you can have. So we'll be able to send JSON to Azure SQL. There we'll decide how to actually store the data. I have decided to store data as a regular table, but I could have also stored it as JSON. Do some manipulation, send back JSON to the backend API. So it will be super easy to deserialize what we got into an object and then send it back to the client UI to visualize the result on the front end. That's exactly what we are going to do. Now, to start is super easy. You have to download or install the Azure Function core tools. And here's the link and the instruction to do that. You have to download and install the static web app CLI because that will make our life super easy. And I love so much this CLI that has been created by the static web app teams because make local development just a dream. I will show you in a second. And then I can't just type all the HTML right now because otherwise we'll be out of time very soon. Even because I'm not an HTML guy, I'm not super good at creating a front end. I'm better with the back end. So I will be just downloading the Vue client and start from this one to evolve it so that it can connect to the back end, can send data to database, and do exactly what we just did. So starting from these three simple things, let's just summarize what are the next steps that we are going to do in the next 20 minutes. So create an Azure function to implement the To-Do MVC API specs. Of course, the front end will be sending some JSON, but how should we manage that JSON? Should we support a get, a post? How shaped is the JSON that we are going to receive, and how the JSON should be shaped to be correctly manipulated by the front end? So in this To-Do backend website, there are the specification that you just have to follow in order to make a backend compatible with the front end. And then we will update the Vue client so that we can use the REST API created. And then we will deploy the Azure Static Web App to the Azure Static Web App Engine. And then we will change the API so that we will be storing the data into the database. And then we will do everything with the CI/CD pipeline because actually deploying the full working solution that I have on my machine to the Azure Static Web Apps can be done. And actually, it's really easy to do it using GitHub Action. And that will be a dream. You just push. At some point, you will just push your changes and it will be automatically compiled, built, and sent to the Azure Web App for production. And then we also want to add authentication support. Then finally, we can have some good chocolate and enjoy what we have done. So let's do it, but not before having explained why I decided to use Azure SQL database and not something else. Well, as I said, I'm really starting from scratch here. I don't know where this application will be in 5 years. So I want to be able to be super flexible. So I need to be flexible, but I only need to be secure and performant and make sure that our data is consistent. So I want to be flexible in the sense that I want to be able to support any kind of model I may want to use in future. So JSON, so the documents, graph, and geospatial. Maybe I need to have super high concurrency. So Azure SQL provides in-memory lock-free table, which are tables that does not take any lock to implement the consistency of transactions. So you can really have, thousands and hundreds of thousands, even million transactions per second on those tables. We even may want to have a ledger table to make sure that all the trail of our data is proven and consistent. We may want to use the column store to quickly aggregate data and provide reports, for example, or dashboards. We want to encrypt our data, maybe. We want to apply row-level security. So all these features are within a single database, and you can pick and choose them and use them together as you wish. So it makes super easy for me as developer to improve my application over time, taking advantage of any of these features. And specifically, I will use the serverless version of the Azure SQL because it provides all the features I just mentioned. But in addition, it will also help me to automatically scale up and down when it detects that there are more workload. It can automatically pause itself when I'm not using it. So when I stop working on it, especially for development purposes, I will not pay a cent for it, and it's billed per second. So exactly in a serverless fashion, I only pay when I use it, and for the second I use it, which is great. So let's do that, and if you want to follow me, everything I'm showing here is already on the repository you can see on the screen. There are 3 branches. The first one is the very basic one, the one I will show you right now, and then the version 2 is with the added ability to send data to the database, and the third one is also with authentication, so you can only see the to-do item that you have created, really completing the end-to-end story of professional, fully working and solution. So here we go. Let's switch to code and build something right now. So first of all, I wanted to show you how easy it is to create the static web app. So I just want to create a directory here. So let's call it Kickstart, and then within the Kickstart, let's create 2 folders. Let's create the client folder where we will store the front end, and then make also the API folder so that it can store the backend code. Let's see what we have. Perfect. Now what I want to do is quickly download in the client API, in the client folder, the HTML that is provided by Vue, the Vue team that already implements basically the to-do list, just using Vue and local storage. But this is exactly what I want to start from, right? So this is what impressed me about static web app and Azure Function. It's done. So I downloaded something that I want to use as a starting point. All I have to do right now is SWA start. I don't have the API yet. So let's just start the client. Fully working and super rich emulator started. I can just go here, and here you go. I have my application working. And of course, hello again here. So this is my application. It's working very nicely. The only limitation right now, it's everything is stored in the local storage. So local storage means, and let me switch to the V1, which is basically exactly this application. But the local storage means that, let's go here. Local storage view page source. So local storage means that this code here, which will probably you recognize if you are familiar already with Vue, is basically saving the item I created into the storage, in the local storage of the browser, right? But then, as you can see, I have a function for when, for example, here we go. I add a new to-do, I remove a to-do, or I edit one. So what I really have to do is now change this code. So instead of calling the function that use the local storage, it will actually create call a REST endpoint. And how can I create a REST endpoint? Well, that's super easy. Again, now let's do something kind of super easy right now. So let's go to the API. What I have to do is just initialize the function environment here. And then I want to create a function written in .NET. Here we go. So here everything is done. Now I want to create a function called to-do, or and using the HTTP trigger, which means this function, when deployed, will answer it to some HTTP call, where I will write the code to actually handle the to-do that I receive, save it into the database in the future, and so on and so forth. That's it. So again, I can go to my folder, now use SWA and add API. And this means that the local environment will actually start the front end, even start the back end, and serve them and make sure that they work well together, taking care of otherwise complex configuration like cores and all this stuff that you usually have to take care of yourself. Now, of course, this is nothing different than before, because my front end doesn't know that the backend exists yet, but we can check if the backend is actually working correctly. And the backend is answering at this address, localhost API to do. So if I send a GET, I should expect to receive something, and that worked. So the function is actually working. Now the function has been created using some boilerplate code. So it doesn't really do much. For example, if we go to the API, and for example do cat to do, which has been created for me when I did function new, you can see it's just an example on how to handle get and post request and then return something. But this is exactly what I need to get started. Now I can remove all this code, put the code in order that will send or store the to do somewhere, and then I'm done. Now, this is just the basic step that you need to get started and to have some working code. Now we have to change the code to make sure that it does what we want, not what the boilerplate code already does for us. So having said that, let's go to the V1 branch of the repository. And here you will see exactly what I did. So the index.html. The only difference between what you saw before and now is that now my index.html has been changed so that it can send data to a backend API instead of using the local storage. And specifically, I'm using the fetch method so that I can send the JSON that nicely the Vue.js framework will give to me and send it to this API. The API are nothing more than just the localhost / API to do in this case. And so my API will be done in this way. Here, for now, I still don't want to connect to database. I just want to create some backend code that is able to handle the JSON that is sent from the front end. I'm just using a list to simulate an in-memory database. So I create a few to-do items, put it in the list, and then I wrote the code to implement the get handler for the get method, the post handler for the post method, and so on. And for example, the get is super simple. If you go at to-do / an ID, I will try to, first of all, I will check if you are specifying some ID. If not, I will send back all the to-do. If you have specified an ID, I will look if there is any item with the ID you specified. If yes, I will return the item. Otherwise, I will return a not found. Super easy. Now that we know how the SWA CLI work, we can just do, so here I'm already in the repository, I already cloned it, it's already on the V1, so all I have to do is, as I did before, start my my emulator here, and then this will start the updated HTML that is able to send via the fetch method a request to the backend, and the backend is now able to get the JSON that has been actually sent from the front end. So everything here should work nicely. Perfect. I have hello world and world hello that are exactly the sample item I created, and here I can, for example, create a new one, new to do. This will be stored in memory. I can now mark it as done. Perfect. So this is working. Now the only problem is that it's saving everything in memory, right? And now we want to change that and connect it to the database. But this is something I could already deploy. And deploy means I can now, since I just have 10 minutes left. I can just run this ARM template, and the ARM template is basically a way for you to tell Azure what you want to be created, so a description of the resource you want to be created. And as you can see here, I'm creating a static website. And the static website needs a source repository URL, and my repository URL will be exactly this repository here, which is the one that you should fork and then use as your deployment starting point, that contains the code that is actually running now locally, right? So if I move forward and deploy the ARM template using the Azure Deploy shell script I provided, which is actually executing the deployment, you will end up using a static web app fully working, which is actually exactly this one. Now, in order to just show you everything, I want to move now to the V2 of this application so that you can see how easy it is to connect to the database. Because now the front end doesn't have to change anymore, because we know that the front end is sending and managing correctly the JSON. So no matter what happened in the back end, as long as we send back and basically manage the JSON in the same way, we can do whatever we want in the back end, and the front end doesn't have to change. And in fact, here, the only thing I did is I converted the logic to get to manage the get and the post and all the other method, so that instead of saving into in-memory list, I'm sending the data as JSON. So I'm getting the ID, wrapping it into a JSON object, and sending it to a storage procedure. The storage procedure here, which is this one, will actually execute some SQL code, and that SQL code will actually return a string, which is JSON. So I'm doing something on the database, but the output of the database is JSON itself. So it's super easy to parse it into JSON. Here I'm just returning it as JSON. I could have deserialized it into a to-do object if I also wanted to apply the schema here in the application. And how my database would look like, super easy. My table is incredibly easy. So I just have a to-do with the ID, to-do and completed. But my storage procedure is just taking JSON and returning JSON. So from a developer perspective, even the communication with the database is full JSON. And this means that as a developer, my life is much easier, because then I can simplify my code, because I don't have to deal with rows and columns and table and other stuff. I just have to have serialize to serialize and deserialize JSON, and that's it. So for example, here what I can do is create a database, and I will show you how even this can be automated in the process. But just for the sake of the time we have available, I already created a database. Now let me connect to it. And I'm just using the query editor here. Let me clean it up to make sure that my demo will work as expected. Perfect. And now I want let's stop this. What I want to do right now is deploy the database, right? So I have a database. I just want to deploy this SQL. There are several ways you can do that. Some other ways will be shown by Anna in his session tomorrow. Here I want to show a way I like a lot, which is writing a script and executing the script in a smart way. What smart means? Well, for now, I just only have one script. So I'm using a tool called DB app that will automatically get all the script in this folder and apply them in the correct sequence on my behalf to the database. So all I have to do is go to the database deploy folder and do .NET run. This will connect to the database and execute the script. And as a result of that, I will have the database deployed. Nice. So if we can go here, we can go here right now and take a look at what's in the database right now. There is the to-do table I created, but also there is this $DB app journal, which basically is something that is used by the DB app library that I used to keep note of what script has been used already and what not. So if I re-execute this script, this deployment, it will not execute the script that has been executed before again, which means that I can deploy my database incrementally, which is great, right? Now, having deployed my database in my dev environment, what I can do here, everything is ready, my code is ready. What I can do is just, well, we can close this. Let's move here, clear this up, and run again my solution. Again, this will now be started. Emulator will spin up the server to serve the HTML front end and also the function to serve the backend. And everything will work super nice in the sense that now I can go here and here we go. With these values, now let's see, I have slides and demos here. I can go to the portal. Actually, it's here. So I can do select from dbo.todos, and you will see that we have slide and demos. Now let's go to the same page and say, hi there. And let's say that I done the slides. So let's go to the database, run the query again, and you will see that everything has been saved in the database, right? Perfect. So this means that I coded my application correctly. My front end is correctly sending data to my backend, and how my query would look like. So for example, this is exactly another example of just using the API without the front end here. So let's say I want to have all my to-do. I can just request this, and this is exactly the JSON that has been sent back to the front end in this case. If I want to create a new API, all I have to do is post to the endpoint, and this will actually create an API. So, and this is exactly what has been sent also to the database, and the database is actually sending back this. The backend is now basically working as a translator between the front end and the database to make sure that the JSON sent is correct, can be validated, and all this kind of additional stuff that for security we want to keep. Now, this is super beautiful, I would say. Now, let's make it a little bit more realistic, because as you can see right now, anyone can actually come here and create a to-do, and I would be able to see the to-do created by anyone, but I want to be authenticated. I want to make sure that my to-do are only visible to myself. Now, the really beautiful thing about the local emulator, the static web app CLI, is that it also comes with an integrated authentication system that allows you to simulate OAuth2, so that you can actually simulate you connecting to a GitHub resource authentication provider or Twitter, so you can really have a fully working experience even locally. How we can do that? It's extremely easy, I can tell you, and we just have to switch to the V3, where there is also the authentication code inside the authentication mechanism inside the code. And you can see here that I am just querying this .out.me, which is something provided by static web app that would allow the code to understand if I'm logged in or not. If I am not logged in because this doesn't return anything, I just have to log in, for example, using GitHub. This works like magic. Let me show you. So let's go here. Let's start again my simulator with now this additional code, and you will be able to see that everything works perfectly as expected. So just okay, perfect. Here we go. Let's go to this and refresh. And now you can see that I can log in here. And so let me try to log in. And here I can simulate the fact that I'm logging in with GitHub. And then I can log in, and then I'm logged in. And how do I know who is the user who connected to my application right now? Well, again, Azure Web Apps make everything super easy. In my code, all I have to do is parse a special header that has been set up by static web apps for me that contains the information that has been received by GitHub or Twitter. So super easy. I decode basically this header that contains token information, and then I can have, for example, here a user ID somewhere Here we go. For example, here I can extract information about the context, which contains the user ID. Perfect. Now, this would work locally, but now let's pretend that I already done everything I need to do. I tested it locally. I want to deploy it. So to deploy, as said, I just have to run this ARM template. So let's do that. Let's stop this here and just run Azure deploy.sh. This will actually create a resource group and will actually create a resource group that already exists. So it will be super fast. It will, let's see if I can make some space here, apparently not. So it will also create a new database. Well, actually, that's not going to do it because that's something we have to do. But we know that we need to have a to-do database here created. What it will be doing is creating a to-do app. Actually, I already prepared the to-do app in case we don't have enough time to do everything. So the only thing I need to do here is to change the name of the to-do app. Let's call it live. Nice. And let's deploy this again. And perfect. Here you have to specify other information. So the environment is something you have to create, but the shell script I prepared will help you. Basically, you have to specify where you want to deploy, the connection string to the database, and some information so that you will see the static web app client or deployment will actually create a workflow in GitHub for you. And actually, this is probably already done. This is usually quite fast. And what will be happening is that if I go to my GitHub repository, soon here I will see a workflow with the name of the application. So my application has been created and internally as a random name called Delightful Island. So if I go here to the workflow, I see Delightful Island. Perfect. This is actually what gets kicked in every time we commit something, and it goes and deploy the application, build the application, deploy the application on Azure for us. Now, the only limitation of this workflow here is that, of course, it doesn't know that I'm using a database, and I want to also include the database creation in the process. So to show you how you can do that, I also prepared a sample you can use. And literally, you just have to copy and paste from the action to the deploy and build. So let me do that. Here we go. You can go here. So I said from the action to deploy and build, so it will be exactly here. Nice. Let me correct the indent is done. Start commit, commit changes. Perfect. From now on, every time we commit, also the database will be deployed. And as you saw using dbapp, all the incremental script will also be deployed every time I add a new script to my database, so I can also evolve my database. If you go to action, let's stop this, cancel run, so we can just focus on the second one that contains also database deployment. This, in a couple of minutes, will actually deploy the solution, deploy database, and we will be able to actually have a fully working end-to-end solution that implements even security on Azure static web app with Azure Function backing it up for what concerns the API and Azure SQL for what concerns data management. This usually takes a couple of seconds, and this is also the end of my demo. So in the meantime, this deploys. If there are any questions, I am more than happy to answer some of those. So let me bring back my
hi, Davide. I think you're probably not watching the Learn TV chat, but it's been going crazy. There have been so many questions that have been answered. I hope you get a chance to go back and look at them.
Definitely.
I'll bring up one which I don't. Someone had just asked, is this a specific pattern for static web apps? And I think they're talking about your whole kind of end-to-end workflow. Quick answer.
So yeah, the pattern would work with any technology you want to use. A static web app make it super easy because otherwise you have to do everything on your own, right? So you have to figure out, how to, for example, configure the front end to make sure it can work with the back end. And usually CORS, which is something that usually tries to make sure that you don't get hacked, is something you have to configure. Is not always super easy. This basically remove all the friction and give you just an amazing experience.
Yeah, that was a question from Raj Krishnan, and thank you so much for that. I also wanted to say I love the CLIs. I mean, this is such an amazing session. You made it so seamless. But a quick question for you. I think we also have VS Code extensions for those of folks who prefer that.
Yes,
There's a ton of stuff with SWA and
Yeah, there is a code extension for static web app. I haven't used it just because I'm more a code guy. So
yes,
I like typing. But yeah, definitely there is also a code extension that will make everything even easier. Yes, absolutely.
So I'm going to put a challenge to people out there. David was using Vue, so you should fork this and do this with other frameworks and write up your articles on how you did this with VS Code. That would be awesome.
Yes.
Thank you so much. This was so amazing. I'm going to actually go back and watch this and write it up because this is exactly what we need.
Thank you.
Thank you so much, Davide. And I think we have a quick minute where we're going to go show you a video about data exposed from Anna Hoffman, who will be talking tomorrow. Let's go to the...
Hi, I'm Anna Hoffman from the Azure Data Product Group, here to tell you about a show I host called Data Exposed. We talk about all things data, what's new, deep dives, how-tos, and we even give you a glimpse under the hood from the people who actually build the products. We cover topics like
Azure SQL Security,
running high-performance SQL Server workloads on Azure virtual machines,
migrate all your database assets to Azure SQL,
data science with something old and something new,
Azure SQL Managed Instance,
developing apps with Azure SQL Database,
and more. We post short episodes on Thursdays, and once a month on Tuesdays we release a special MVP edition with the community.
May the 4th be with you.
Catch us live on Learn TV on Wednesdays at 9 a.m. Pacific.
I love that Data Exposed. It's one of my favorite things to watch.
Yeah, and I think Anna's going to be doing a talk on this conference soon too, so I'm looking forward to that.
Yeah, everybody should watch that one. Anna's such a great speaker. But coming up next, we have another great speaker. And I'm really excited for this session. It's going to be so much fun. Highly scalable games with Azure Serverless with Labrina Loving. It's going to be awesome. So let's watch. Hi, Labrina. Are you ready for this?
I am ready. Let me just share my screen. Can you guys see my screen?
We don't see it yet. Oh, now we do.
Oh, yay! Woo! We're so excited.
So yes, I am so glad to be here. I've done a couple of conferences here before, but this is my first time talking about gaming. So I'm excited to be here. I'm excited to talk about how serverless can help game development. So as everyone mentioned, my name is Labrina Loving. I work in developer advocacy for our gaming ecosystem organization here at Microsoft. And today we're going to talk all about building highly scalable games with Azure Serverless. So over the years, games have gotten more data intensive, more compute intensive, and there are some amazing games out there that are really leveraging the power of cloud. But I wanted to have a discussion about how we can actually leverage the power of serverless. So today you might actually be hosting your game on-prem, or you might be hosting your game and the services that support the game. Maybe you might already be hosting it in the cloud, but you might be using something like virtual machines. So today we're going to talk about how you can leverage the benefits of serverless to host your game. So for today's games, there are a lot of online services that actually power games. Games require a lot. Things like leaderboards, matchmaking, authentication, player-to-player messaging, currency, tournaments, and analytics. And on top of that, if you're doing multiplayer game, you have to worry about hosting. And as always, you have to worry about the ever-growing scale of player data. So there is a lot to think about, a lot of services. And although you may already have created services for some of these, it's really great to leverage serverless as a way to actually take some of the burden off your development. So today, hosting options for your game come in a lot of different flavors. So, and the flavors, it's definitely a choose your own adventure. And the way you think about it, this is really about how much you want to manage and how much you want Azure to manage. And that can vary based on the requirements of your game, and based on just where you are in your cloud journey. So we start all the way over at the left when we talk about infrastructure as a service. That's definitely where we at Azure are managing the infrastructure, hardware, and networking and the facilities, but you're still managing patching of servers, you're still managing application code, security, config, provisioning, the list goes on. Then let's talk about a little bit container platform as a service. So this is where you're actually having your game and its services are running inside of a container, and Azure is maintaining the container orchestration plane, still also the physical hardware, software, and facilities. And then you manage the application code, the data source integrations, and you're managing those container clusters. And for that, we have a service called Azure Kubernetes Service, or AKS. Then there's Platform as a Service, which is where we will continue to do all those same things, but you're managing the scale of the web application. And then there's Functions as a Service, which is what we're primarily going to talk about in the session, which is where at this point we as an Azure are managing everything except for your application code, except for your game development code. So you can focus on building your game, and we focus on everything else for you. And then the last thing in the corner, which is last service in the corner, which is really great, which is Integration Platform as a Service. So this is, we have a service called PlayFab. And with this service, it actually comes, a lot of the services that we talked about, like leaderboards or matchmaking, can actually be services that you configure. And then you could possibly combine Function as a Service and Integration Platform as a Service together to extend PlayFab as well. So you might be thinking, if you're already building your game, why should you use serverless? Why is serverless important for gaming? So with serverless, you actually can scale automatically. We handle the scaling for you. We manage high availability. We manage the servers for you, and you kind of focus on code. It's very cost effective because in this case, you pay only for the compute time that you use. So if you have a leaderboard that is running in an Azure function, you pay for the time that leaderboard service is called and doing work, and then you don't pay for and then you're done. And then so actually in this case, you're paying for just the compute time for processing those particular events, and that's it. And then because of this, you actually just can focus on your game, not on provisioning infrastructure, figuring how much infrastructure you need to buy, figuring how to scale it, how to replicate that infrastructure across the globe. We manage all of that for you in Azure. So let's take a look at kind of the inventory of serverless features and options that you can choose for powering your game. So we talked a little bit about Azure Functions. So Azure Functions allows you to run compute, and it allows you to run application game code in the cloud, and you can run various services. It can be event-based. It can be triggered off of things like messages that happen. It can be triggered based off of an HTTP endpoint. It can be time-based triggered. There are a lot of different event-driven ways, and it feeds really well into your event-driven architecture. API management is our front end for having security in front of your environment. So it handles things like SSL offloading. It can handle security, other things like that. Then Event Hub and queues can be used for managing your messages that could scale at scale. So as you're streaming events, telemetry events for player data, you can use Event Hub and queues to manage that. Stream Analytics is our stream processing service, and Azure Cosmos DB and Azure SQL are our database, Azure Cosmos DB for NoSQL, and Azure SQL for relational databases, and Blob Storage for unstructured data. And then to kind of monitor and support all of the events and all of this, we have Azure Monitor and Application Insights. So what I thought I would do is actually take a look. Let's take a look at a reference architecture for actually doing something in your game for matchmaking. So when typically when you're doing matchmaking, there is a lot of concerns that occur, figuring out how the logic to match users across the globe, figuring out the right latency, figuring out how to minimize latency, and then still handling things like what happens when the user might cancel or leave the game. So there's a lot of concerns that can happen while managing your game. And so we can leverage the power of the cloud and serverless to do all of these things. So let's take a look a little bit at the diagram that I have. So let's imagine that we have a game player that comes in through a device client. They will get added to a queue. We will use Traffic Manager and API management to route their requests to the closest region. So if you have users coming in from Europe or from Japan or from the US, they will get routed to the appropriate Azure region that's closest to them. Then that request gets placed on an Event Hub. Then we have a Azure Function that actually will take that message and process it and figure out where this player creates a ticket for the player, a message, and tries to figure out the appropriate game session for that user. Then we have another function that will add the player to server. Then we have this kind of a layer at the bottom where we're doing a match request. And that actually is an orchestration that happens. And so during that match request, we create another Azure function to determine where the player should be matched. And then we and then when we're done, we figured out the right matching, then we can put a message on the Event Hub and trigger that, and then the player is ready to start playing. So I'm going to show a little bit of the code behind the scenes for how to make this work. second. So here I've got a set of Azure Functions that I've created. So I've got an Azure Function called batch add player. And this is triggered, as you can see, it's triggered from my Event Hub. And then what that does is it starts kicking off an orchestration. And what that orchestration can do is start connecting and figuring out where the player should be matched to. So I've got some processing logic here that just takes the player information and deserializes it. And then I start creating a hash key that'll store in a Redis cache to maintain the session information for the player. And so this code actually is pretty easy to get started. And then once we have this code written and set up, then I can actually deploy that as an Azure function. That Azure function would be running in the cloud, and every time a new player gets added, requests a game server, requests a match, this code can run. And so it can run at scale, and basically after you write your matchmaking service, you actually deploy it and you're done. You don't have to worry about hosting. You don't have to worry about other infrastructure concerns and scaling. This is all done for you. So I've got just to kind of show, I've got a bunch of, I've got a quick little game that I'm gonna just play real quick and start firing off some events. And then what I'll show happening is that when I start my gameplay, we'll actually be able to see that in our server. So let me get that going. It's taking a little bit of time to get my game started. So anyway, so what I've done is I've provisioned what is called an event hub. An event hub is what we use to store all of our player data, telemetry, and messaging. And so, I can take a look at this event hub. I've created an event hub. First thing you do is you create an event hub namespace. And then what I've done is went ahead and created an event hub instance. And this event hub instance, I've called it player data. I've actually started capturing events. So you can see over time, like the number of requests I started pulling in. So I've got like over 3,000 requests that I just started pumping through from playing my game over, or simulating playing my game over time. And so you can see these events have been captured here. And the code that I showed before, my game server, what it does is it actually connects to those Azure functions, which then places the events on an event hub and then triggers the remaining code to actually do the matchmaking events. Okay, so let's take a look. So now that I have, I'm my player events and telemetry going to an event hub, and I've got a lot of player data and matchmaking happening. One of the things that I want to do is start doing some analytics. So the great thing, but because of the way that game data is growing, there's some challenges with doing gaming analytics. So data is very critical and to game success. And there's an ever-growing amount of telemetry over time. There's a lot of siloed data that's aggregated. So you might have player game data, you might have player profiles, you might have just the actual gameplay that's happening. So you'll have a lot of data that grows over time. And it drives a lot of important key decisions on how you grow your game, how you continue to evolve your game, how you monetize and keep players coming. And you really want to be able to have the game data to be provided in real time to power decisions. So, and then you want to be able to bring your existing tools to analyze the data. So what I want to show as a second is to really show how you can use the power of serverless to actually stream data in real time, be able to make decisions as well. So let's talk a little bit about the tools that we'll use for streaming data in real time. So the first thing we'll be streaming that Event Hub data that we started creating when a player from our player events. We'll use another service called Azure Stream Analytics to stream it. And then I'll show a little bit of how you can use different reporting tools of your choice to actually report and visualize that data. So let's go back to our Azure portal. And so what I've already done is I've provisioned a stream analytics job. And when you create a stream analytics job, there's a couple of things that you want to do. So the first thing that you have to do is you have to create your inputs. So I've created already an input data stream, but let's just see how I could create an additional one. So when I create an input data stream, I can actually create it from either an Event Hub, IoT Hub, or Blob Storage, but I'm going to create it from an Event Hub. And so this gives me the idea. Oh, my job is still running, so I can't actually show. But so this actually will walk you through creating an Event Hub. Well, let's take a look at the one that I already have created. So I just went through and created an Event Hub. I created it from my Event Hub namespace. Called player data. Here's my Event Hub, and then it just creates the connection string. And then it creates a policy. Policies are used to create fine-grained control to your Event Hub and to your data. Actually, I'm going to go ahead and stop my job so we can actually execute a few queries too. So the next thing that I'm going to do is I'm actually going to create an output first. And you can add outputs as well. There's a lot of different ones you can create. I created a Power BI output. Power BI output will actually allow me to connect and stream my data in real time and connect it to my job. So actually, at the end of the day, just with a few clicks, I can stream player data in and then actually connect it right to a Power BI report. So here's here's my Power BI outputs. I've created a data set called player data set and created a table here. We'll quickly see how that works. Just doing a quick time check here. And then as you can see here, there are various ways that you can output your data. You can output it back out to an Azure function. You could store it and keep it in Cosmos DB for other considerations. You can put it in a data lake so that you can combine it with other data to do other further analysis. But I've created mine out to a Power BI report. And then what I wanted to do is actually kind of show a little bit about this. So I'm capturing things like player country and the number of game counts and things like that. And so what I've done is I've created a query, and your query is what you actually do to capture the data as it's streaming in from Event Hub. And then what I've done is I've created a tumbling window to capture it every, this is a tumbling window every 5 seconds. So if I test my query, oops. Oh, I may not have it. I need to stream some data. But this actually would show our data for in real time. And then at the end, I could now go to my Power BI report and actually show my data in being captured in real time. So let's see if I can get this kind of started again. And I'll just quickly show, because I know it looks like we're running a little bit low on time. So I'll just quickly kind of show the process of actually taking that and combining it with Power BI data. So if I go here. Just bring up my report. I'll see because I created the because I already created and connected my player data. I've now got a data set here that I can see through my Power BI report. And then I also can create a Power BI dashboard to capture that player data. So really just within a few minutes of simply clicking, you can take player data, ingest it, query it, and then be able to output it to do like real-time streaming to your dashboard. Let's see. Since we're running a little low on time. So that's sort of our those are sort of two instances where you can actually take leverage serverless for using, for improving and building your game. So we talked about actually using serverless for actually running all of the APIs and functional code for your game development. And then we talked about using serverless for streaming your data in real time. And I know.
Thanks very much. That was great.
Yeah, thank you.
We had a quick question for you, if you have a minute. Sunita was curious why you chose Event Hub over storage queues or Service Bus.
Yeah, so the reason why I chose Event Hub over storage queues, over storage queues and storage bus. So the reason why you think about the difference between Event Hub and queues are really you have to think about what the purpose of what you're doing. So event hubs are best used for events. So saying like this happened, like this player is requesting a matchmaking event, or this player quit the game. So those are actual events where I want to take further action versus the queue, where it's really about just sort of reading data. So that's actually why I chose an event hub versus a storage queue. But in some cases, it could work very well the same, but it also depends on the scale that you're looking for as well.
Yeah, that makes a lot of sense. We have a lot of good sessions coming up. What's coming up, Nydia?
Yeah, and Labrina, we got to talk after, so I'm going to go. That was awesome. So thank you so much. And we are off to the next session. We're going to have, throughout this conference, you've been hearing about Power Automate and Azure Logic Apps. Now we're going to hear about it from Prashant Boyar, who is an MVP, and also here to talk about how, or kind of contrast Logic Apps with Power Automate. Take it away, Prashant.
Thank you. Thank you, Nitya. Thank you, Melody. Let me start sharing my screen. All right, let me know if you can see it. All right, so good morning, good evening, good afternoon, depending on your time zone. So in this particular talk, we'll be focusing on key differences between the Azure Logic Apps and Microsoft Power Automate. So who am I? My name is Prashant G. Boyar. I was raised in India, came to the United States in 2007 for studies, and University of Maryland College Park alumni, co-authored a book called PowerShell for Office 365. I also acted as a technical reviewer for the book Pro SharePoint 2013 Administration. I am from Washington, D.C. area, and we organize a lot of community conferences. Pre-COVID pandemic, all the conferences used to be in person. Ever since the pandemic has started, we have converted all our conferences to virtual only. So if you're interested, here's the link, and you can find more information about the registration and the call for speaker and rest of the stuff. I am recipient of Antarctic Service Medal. I got this award from US government for the work I did in Antarctic continent back in 2008. I am recipient of Microsoft MVP Award since 2017, and my current category is AI. And those of you who are not familiar with this award, so I don't work for Microsoft. It's just the additional recognition that Microsoft gives out to the folks who does technical contributions via various ways. And currently I work as Cloud Solution Architect at AIS, and I focus on intelligent business process automation, where I use variety of the products and services in Microsoft ecosystem like Azure AI, bots, Microsoft Power Platform, Microsoft 365, and SharePoint. And I work at AIS Reston, Virginia headquarters. So this is going to be the agenda. We'll start with a brief introduction about Power Automate, a brief introduction about Logic Apps, and the majority of the time we'll be spending on talking about the key differences between these two products. I'll also talk about how to extend Microsoft Flow or Power Automate using Logic Apps, key takeaways, and Q&A. So feel free to ask your questions in the chat window. Nitya and Melody are here to monitor those, and they will be letting me know as and when the question will arise. So let's talk about the Power Automate. It's a low-code platform that spans across Microsoft 365, Dynamics 365, Azure, and standalone application. And one of the early member of Microsoft Power Platform was Power BI. And later on, Microsoft introduced Power Apps and Power Automate. And recently, during the November 2019, Microsoft introduced Microsoft Power Virtual Agent, which we can use to create intelligent chatbots without writing a single line of code. Now, we use Power Automate to implement end-to-end intelligent automation. And these are the value pillars of Power Automate. We can do automation at scale. It's seamless, secure integration. It builds on the serverless principle. It helps us to accelerate productivity, and we can implement intelligent automation using Power Automate. And there are many connectors available. The list is keep on growing. Right now, it's more than 300, and you can build your own custom connectors as well. And with that connectors, you can integrate with your data, not only in the cloud, but also in your on-premise legacy system as well. And there is a growing list of template libraries available. So in case you would like to implement certain kind of automation, you can quickly check out a template library. And there you can find how to implement a particular set of automation. Let's say where you have some events happening in Azure Event Hub, and later on, you would like to do some operation in other non-Microsoft specific system, let's say Google Drive or Dropbox, or let's say AWS, then there are a lot of templates available that you can use. Now let's talk about what are logic apps. Logic apps is a cloud service that helps us to schedule, automate, and orchestrate tasks, business process, and workflows. It is a de facto workflow engine in Microsoft Azure. It again, just like Power Automate, it's built on serverless principle, and it uses containerized runtime in the backend. Depending on the usage, it can scale up and down automatically to meet the demands. And one of the key advantage of going with logic apps is you can focus on then implementing your business logic. You don't have to worry about where my logic app will be hosted, whether that environment is going to be secure or not, how I make sure it has the latest patches, those kind of things. You don't have to worry. Just straight up go to the logic apps portal, Azure portal, create your logic app, and start implementing your business logic. Just like Power Automate, there are many connectors available, and we can use connectors across the cloud as well as on-premise. And everything begins with a trigger. And there are various triggers that are available, which we'll talk about in a few minutes. And the triggers can be time-based triggers, it can be manual, and it can be event-based trigger as well. And now if you look at the description or the overview of Power Automate and Logic Apps, they sound a little bit similar. Now let's see how these two products are connected with each other. So if you had to visualize how these two products are connected together, you can use this diagram. So Azure is one of the Microsoft public cloud offering, and Logic App is the workflow engine in Azure. And back in 2016, when Microsoft announced about Power Automate, or it used to call Microsoft Flow that time, it was built on the top of Logic Apps. That means pretty much everything you can do in Power Automate, we could do in Logic App. But over the course of time, Power Automate added its own feature as well. So there is still overlap in between the functionality of these two products and services. However, now these two products and services also has its own unique feature sets that are only available, let's say in Logic Apps, are only available in Power Automate. The designer, the lot of actions and trigger are still common both in Logic Apps and Power Automate. And when it comes to Power Automate, we can create business process flows, desktop flows, and additional actions that are now not available in Logic Apps. However, since Power Automate is built on the top of Logic App, whenever a cloud flow executes, the runtime it uses in the backend is actually the Logic App runtime. As you can see here, whenever your flow starts, it uses the Logic App runtime. It makes the API call integrate with all the services that you're using in your flow, and finally your flow get executed. So if I show you this diagram here, so I have here two screenshots. Both the screenshots are implementing the same business logic. We're basically starting automation whenever a new item is getting created in SharePoint. Then we are initializing a bunch of variables, and then we have some condition. And if I hide few information from the ribbon and from the left-hand navigation, it's very hard for us to figure out which one is Logic App and which one is Power Automate. You can take a guess, but let me remove these banners here. So you can see here, the one on the left is from Logic Apps, and one on the right is from Power Automate. But if you focus on the middle section, where the actual business logic is implemented, it is pretty identical. That means if you are familiar with Microsoft Flow or Power Automate, then you can implement a similar business logic in Logic Apps as well. Only thing is you'll be going to Azure portal to implement that. Similarly, if you are familiar with Logic Apps and how to build your business logic around Logic Apps, then if you would like to use Power Automate, you just have to go to a different URL and Power Automate UI and start implementing your business logic. So let's talk about the key differences between these two products. So the first one is Logic Apps is part of Azure Group, and Microsoft Power Automate is part of the Business Apps Groups or Dynamics Group. Now you may be wondering why I'm talking about which product group these products belongs to. And there is a reason for it, because depending on which product a particular product belongs to, you'll see the corresponding other products from the same umbrella will have a really tighter integration with that. For example, Logic Apps will have really good integration with other Azure DevOps and some other services. And in example of Power Automate will have very tighter integration with Power Virtual Agents, Power Apps, which are the part of business app flows. When it comes to the offering, so Logic App is available to us as integrated platform as a service offering, whereas Power Automate is available to us as software as a service offering. The licensing model of Logic App is very simple. It is just like anything in Azure. It's all based on your consumption. So we pay as per the usage. Whereas in Power Automate, everything is subscription based, and there are multiple ways you can get the license for Power Automate. The target audience for Logic Apps is IT professionals, and it's built more for enterprise-grade scenarios. And Power Automate use subset of Logic Apps, and the focus audience is citizen developers or people who would like to live in low-code, no-code environment. So with Logic Apps, we can only create Logic Apps. When it comes to Power Automate, we can create cloud flows, which are nothing but Microsoft Flow, business process flows, desktop flows. This is important things to consider whenever you're debating which one shall I use to implement my automation. Shall I go with Logic Apps or shall I go with Power Automate? So the maximum run duration for a Logic App is 90 days, whereas the same duration for Power Automate is 30 days. And this is true for cloud flows. If you are going with business process flows, then yes, you get unlimited run duration. However, for typical scenarios, if I had to compare apples to apples, then Logic App is 90 days, whereas Power Automate is 30 days, and there is no way you can bypass this limitation. Now, what does the run duration means is, if my instance of my Power Automate starts today, then it should finish its execution in the next 30 days. Otherwise, it will get terminated automatically. Now, what are some of the scenarios where you think your Power Automate or your Logic App may run for more than few seconds or few minutes? The scenarios where you're based on a user input. For example, if you're using any kind of approvals, or in your Logic App, you're waiting on some kind of event to happen. And for some reason, that event took more than 30 days to happen in Power Automate, or more than 90 days in case of Logic App, then the instances will get terminated automatically. So keep that in mind while designing your implementation and business logic. When it comes to application lifecycle management, since Logic App is part of Azure, there is a really good story available when it comes to integration with Azure DevOps, source control, and the management in Azure Resource Management. When it comes to the application lifecycle management, we can design and test in non-production environments and promote to the production environment when ready. So the story with ALM in Power Automate is like kind of a bit lagging as compared to Logic Apps. However, it is getting improved day by day. When it comes to PowerShell commandlets, we have PowerShell commandlets available for Logic Apps that we can use, and they are part of Azure ARM.Logic App module. When it comes to Power Automate, we have two modules that we can use. One is called Microsoft.PowerApps.administration.PowerShell, and second is Microsoft.PowerApps.PowerShell modules. And you can go to this link to download the modules for it. When it comes to trigger, most of the triggers are identical. So we have manual trigger available in Logic App as well as in Power Automate. We have triggers based on an event like created, updated, and deleted. We can have Logic Apps and Power Automate start on a schedule. However, Power Automate has one extra trigger which is not available in Logic Apps, and that is a location-based trigger. It is right now in preview. However, there are some really cool scenarios we can implement using the location-based trigger in Power Automate. Now, when it comes to setup and installation, when it comes to Logic Apps, you just need to use a modern browser, and also the code view is available. And we can also use Visual Studio for the development. When it comes to Power Automate, we have to use modern browser. If you have access to Microsoft Teams, and with your current Teams license, you can get access to Dataverse for Teams, then you can use Teams clients with some limitations to create your Power Automate as well. When it comes to integration with SharePoint, there is no direct integration of SharePoint and Logic Apps is there. whereas you will see some built-in SharePoint flows already available. And if I had to implement any automation where I had to do any kind of integration with SharePoint, then I have to create the automation using the Logic App Designer. Whereas if I do the same thing with Power Automate, I can do that using the modern SharePoint UI, or I can use the Power Automate Designer, or I can use Microsoft Teams client as long as I have Dataverse for Teams available to me. Now, what does that mean? Like built-in flows. If you are coming from SharePoint background, and if you open a modern SharePoint site, there in the ribbon you will see an option for automate, and using that, then you can start creating your automation directly into the SharePoint UI. When it comes to integration with on-premise data, let's say your data is in on-premise and for some reason you cannot move that to a public cloud. There is an option for on-premise gateways available with both the products. However, there is one caveat there. So with Logic Apps, you don't need additional license. However, if you would like to use on-premise gateway with Power Automate, you need to subscribe for additional premium license. When it comes to pricing, and that's where the majority of the decision points come, which one shall I use? So when it comes to Logic App, the pricing is very simple. Everything is based on consumption, like you pay as you go. Whereas when it comes to Power Automate, it is subscription based. However, there is a free version of Power Automate available that anyone can sign up as long as they have a valid Microsoft account. Now, what does a valid Microsoft account means? Account with Outlook.com or Outlook.com, Hotmail.com. If you have that, you can sign up for Power Automate for free. Power Automate is also bundled in your Microsoft 65 subscription as part of your Dynamics 65 subscription. You can also purchase some additional plans for Power Automate for per user plan or per flow plan. And also that includes attended RPA. And one of the key decision point I have seen when it comes to using Power Automate, especially if you are getting Power Automate license via a Microsoft 65 subscription, is if you have to use any HTTP action, that is a premium action, and that is not included in your regular subscription. And if I had to use that in my implementation, then I have to go with premium licenses. Now, where I will be using the HTTP action or trigger, if you have to use HTTP call to call Microsoft Graph APIs from Power Automate, if I had to call any external APIs, or if I had to call any Azure Function from Power Automate, or if I had to call any Logic App from Power Automate, in that time I had to use HTTP action. And depending on how you're getting access to Power Automate, that may or may not be included in your subscription. And let's say if you're getting Power Automate as part of your Microsoft 65 subscription, to use HTTP action, you have to go with one of the premium plans here. Now, I see there's a question, can I export a workflow from Power Automate and import in a Logic App? Yes, we can do that. When it comes to exporting that, so since Power Automate is based on Logic App, there is already an option available in the UI. So if you go to the UI of Power Automate, and if you click on this More button, and if you click on Export, there is an option available where you can export that particular flow, cloud flow, as a Logic App template, which is nothing but a JSON file. And then we can take that JSON file, go to the Azure portal, and then we can start use that JSON file and create a new Logic App. However, whenever we do that, we have to reconfigure the connections, any connections that it may be using. And we also reconfigure any action that is no longer available in Logic App. For example, one of the demos, a couple of demos I have, I will show you. Like there is a specific action that is available in Power Automate that is no longer available in Logic App, and you have to do things a little bit a different way. So when it comes to integrating these two, so let's say if I have a business logic and I would like to integrate both Logic Apps and Power Automate into that, how I can do integration. When it comes to Logic Apps, I can call a flow using HTTP action. I can call a Logic App from Power Automate using HTTP action. I can also export a flow and deploy that as a Logic App. So that way I can reuse a lot of the business logic that I have already implemented. When it comes to integration with Power Virtual Agent is the latest member of Microsoft Power Platform, you can use it to create the no-code chatbots. And if you haven't played with this product, I would highly recommend you to just play with it, sign up for the trial. Using this, you can create a working chatbot within 30 minutes that can be used in your enterprise as well. So when it comes to integration between Logic Apps and Power Automate, if I have to call any Logic App from Power Virtual Agent, I have to first call a Power Automate, and from that I have to call the Power Virtual Agent. Sorry. Yes, and if I have to do the same thing, the integration between Power Virtual Agents and Power Automate, there is an out-of-the-box action available where from Power Virtual Agent, I can call a Power Automate. And the reason for that is because both the Power Virtual Agent and Power Automate is part of the same umbrella of the product group. So you'll see there is a seamless integration available here. Whereas here, you have to do some additional steps. Eventually, the same kind of integration will be available, but whenever a new product or service get launched, typically you'll see a really good integration between the umbrella products in the same product group. With that, let's go to a quick demo. Here, what I'll be showing you is I have a Logic App here, which I'm using to create a new Microsoft Teams using the Microsoft Graph API. So let me quickly click Edit. And here, the implementation is very straightforward. It starts whenever a new item gets added in the SharePoint. And when it comes to the trigger, you can have various options available. I can have a Logic App started on a specific event. I can do that manually, or I can also have that based on HTTP request as well. And then I'm initializing a bunch of variables here. And then I'm having a condition, and then I'm doing approval. So the idea is whenever a user needs to create a team, he or she will submit a request, and that request will go through an approval. And here for the approval, I'm using an email-based approval. So if the request gets approved, then only we are using the Microsoft Graph API and creating a new team using the Graph APIs here. Now, similar implementation we have done using the Microsoft Flow. So this is the Microsoft Flow, and you can see here, you have to go to flow.microsoft.com to access it. The implementation is fairly identical. I have this new flow starts whenever a new request gets submitted. Then we initialize a bunch of variables that we require to call the Graph APIs from the Power Automate. Then we do a different kind of approval here. So the approval action we are using here is specific to Power Automate. And this approval action will give you two options to approve. We will get an email. And if I go and expand these action items in the Flow UI, here also you can go and then take action on this particular approval request. And if the request is approved, we are doing the similar implementation where we are calling Microsoft Graph API and creating a new team for us. And let's say if I have to export this particular Power Automate, and if I had to deploy that as a Logic App, what will happen is, since this particular action is no longer available in Logic App, I had to delete this action and reconfigure this action using a similar action that may or may not be available there. So if I had to summarize the comparison, again, these are my personal thoughts when it comes to the comparison between these two products. When it comes to the licensing, Logic Apps wins hands down because everything is simple. You can quickly use Azure pricing calculator and find out how much charge it's going to be it's going to charge you depending on your consumption. Whereas Power Automate, everything is subscription based, and some actions may be premium, some may not be available in your regular license. So you have to do some checking and some math for that. When it comes to personal automation, Power Automate or Microsoft Flow wins hands down. The reason is you can get this service for free, and the free service also comes with a lot of cool features that you can use for personal automation. Now, what does the personal automation means? Personal automation means I'm using some kind of automation for my own work. For example, if I'm going to a conference and instead of checking all the emails, I can have a flow which is integrated with my mailbox, and whenever a mail comes with an important notification, or the mail comes from a manager, I get a notification via a different mechanism so that I can only check email when something important is there. When it comes to the power user friendly, now who are the power users? The people who doesn't want to write code, doesn't write code, or who prefer more kind of low code, no code scenarios. For them, Power Automate is much better. The UI and the ease of use is much higher there as compared to the logic apps, because I have seen a lot of power users struggle to navigate around Azure portal, and you have to use Azure portal to create logic apps. Again, this is my personal opinion. Your opinion may vary here. When it comes to the developer friendly, logic apps wins hands down here because there is a really good integration available with other Azure services. When it comes to integration with third-party system, both are kind of equal. So overall, both the services has their plus and minus. And again, I'm giving you an answer like a typical consultant. Depending on the situation, you may use one or another. But the point I would like to make here is, if you are familiar with Logic App, don't shy away from trying Power Automate. And same thing, if you are familiar with Power Automate, don't shy away trying a Logic App, because there is not much difference when it comes to implementing your actual business logic. So if you would like to get your hands dirty, how we can get access to Power Automate without paying for it for your personal development. So there is a really good program available from Microsoft called Microsoft 365 Developer Program. You can go to this link, sign up for this program. Once you sign up, you can create your personal Microsoft 365 tenant for free. It comes with 25 users with E5 licenses. E5 is the highest level of license you can get with Microsoft 365. And in that tenant, you will have Exchange, SharePoint, Teams, Power Automate, and Power Apps. And using the same tenant, we can also sign up for free trial for Power Virtual Agent as well. Again, you can sign up for the free trial as well. But to sign up for the free trial, you need to use a credit card. To use or to create Logic App, you need access to Azure. So how you can get access to Azure, especially for your personal training and development? There are multiple ways. If you have access to MSDN, that's the preferred way. Just go to your MSDN portal and activate your monthly credit. Here, you don't need to use credit card. So it's an excellent way to try out Azure and play with its services. You can also sign up for the trial. Depending on your country, the amount, that trial amount you get may vary. However, you will need to use a credit card here. There is another program from Microsoft called Azure for Students, where you don't need a credit card. However, you need a valid EDU account from a participating school, and you get $100 credit depending on your country, and you can go to this link to sign up for that. So hopefully the content we covered today made you familiar with the key differences between Power Automate and Logic App. And if you don't have access to a personal developer tenant, definitely check out Microsoft 365 Developer Program. With that, we come to an end, and these are my contact details. Feel free to email me or connect me with, on Twitter or on LinkedIn. With that, thank you very much for coming. Stay safe and stay healthy.
Well done, Prashant.
Thank you.
Yeah, I must say that has to be the most comprehensive coverage of Logic Apps and Power Automate and everything that you need to know about them. I really like the fact that you put those links for personal use, because I think that anytime I look at one of these conferences, I know a lot of people want to go play with it, and to give them just enough that they can go and deploy and try stuff out is awesome. So this was amazing. I know there was one question which I must say you answered in line. I don't know if you planned this, but it was a perfect segue. The other comment that I loved is someone on chat, Simon said, sure, Power Automate and Logic Apps are interesting, but I want to hear more about your Antarctica service medal. So you need to write a blog post on that.
Sure, we'll do that.
I don't know if there's a whole bunch of questions that were answered, so you should definitely go check out the chat. Okay. I had one quick question for you, because we're talking about serverless, and I've heard two really good technologies coming at it from the Azure side and the Power Platform. Do you have a resource for best practices for serverless integrations with Logic Apps? And I know Power Platforms has a practices and patterns kind of a movement, but are there any kind of best practices based on different usage scenarios?
So what you're talking about is the Center of Excellence kit for Power Platform. That's a good way to start with the Power Platform. And if you just search on docs.microsoft.com, you will find tons of information regarding the best practices, not only for Logic Apps, but other serverless technologies as well, like Azure Functions or Cosmos DB as well.
Well, thank you very much. And huge shout out to the 2 conferences you're running. We should definitely amplify them. Can't wait to see that. But I think we are now moving on to the next talk today.
Yep. And that was actually a good segue, as he mentioned Cosmos DB, because our next segment coming up is surfacing FDA COVID data using serverless functions and Cosmos DB. Up with Charles Chen. It's like we planned that.
Hello.
Hey, Charles. Welcome.
Hi, Nithya. Hi, Melody. Thank you so much for having me. Today, we will be talking about surfacing COVID data from the FDA using serverless functions and Cosmos DB. And we'll be looking at a full serverless data processing pipeline to ingest any sort of data, in this case, data from the FDA. All right, so let's get started. So my contact information is right here. If you want to check out the app, you can go to covidcureid.com to see the app running. And kind of like Davide showed earlier, we will be going through a full stack of how to build this type of application. So the session objective, we're going to do a deep dive and we're going to build an end-to-end serverless data processing pipeline. What we'll do is we'll extract the information from the FDA NCATS CureID database, load that into Azure Storage, use Azure Functions to perform the transformation and push that into a Cosmos DB instance, and then serve it also from Azure Functions. So what is the FDA NCATS CureID application? This is a repository that was created by the FDA to house electronic case report forms for novel use cases of existing therapeutics. In many cases, you have doctors all around the world fighting hard to treat diseases. They're working with patients with diseases that are not commonly seen in the Western world. And sometimes they're using treatments that they have on hand or treatments that are available to try to treat these diseases. And the CureID application is a community-driven application where physicians all around the world can contribute electronic case report forms. Now, during the beginning of COVID, when the first outbreak started to happen around the world, this was one of the first places where physicians all around the world came to report their treatment regimens and report the results that they were observing. Now, again, this doesn't have just COVID data, but it has data of all sorts of disease areas. COVID CureID is my take on the application where we extract the information and make it just a little bit more presentable so that given an age and a gender of a patient, we can find all the different treatment regimens and drugs that physicians around the world use to treat the patients and find efficacious treatments so that doctors and patients can potentially find ways to treat COVID. Okay, so let's take a quick tour. This is the FDA NCATS CureID application. So you can see it's organized by disease area. And when you click into a particular disease area, you can see the different types of drugs that the doctors around the world, physicians, have used to treat their patients. And as you click through, it will list the different types of therapies that have been reported. But you can see it's very difficult to find exactly the information you're looking for, and the application is not responsive. So what I did is I built covidcureid.com, which takes the same application from the FDA and makes the information a bit more accessible. So given the age and gender of a patient, we can find all of the cases that are in the CureID application and view it by the different therapies that physicians around the world have tried. And if we click through, we can see the different types of regimens that were given to the patients and quickly filter by whether they improved or deteriorated. And we could click through each of these cases and find details and additional notes. All right. This application is built as a full stack serverless application on Azure. So at the topmost layer is Azure Storage and static websites where HTML, JavaScript, CSS, and image files are hosted. Azure Storage with static websites is an excellent choice for building web applications because it is super scalable, serving your static assets directly from your Azure Storage endpoint. Not only that, it's incredibly cheap. So we're talking about fractions of a penny to run applications on top of Azure Storage static websites. And it also integrates easily with Azure CDN so that you have a true full front-end solution for building modern web applications. At the application level, we have Azure Functions. So Azure Functions we are using it for both the REST API and also to perform data processing and ETL. Azure Functions, for me, is a Swiss Army knife and one of my favorite technologies. I've been working with .NET for 20 years, since the very first beta that came out. And I cannot be more excited about building solutions in Azure Functions. And of course, Azure Cosmos DB. This is one of my favorite databases to work with. At the core of it, it is a super scalable, document-oriented database, but you can query it with a SQL-based API. There is a Mongo-based API, and there is also a graph-based API using Gremlin. So it is a multimodal database that gives you a lot of flexibility in how you can work with that data, and it's also super scalable. So why Azure Serverless? Some of you folks may be coming into the serverless world for the first time. Some of you are already experienced. I want to give you 8 reasons why I love Azure Serverless. Number 1 is a transition from DevOps to NoOps, right? So the beauty of Azure Serverless is you're no longer thinking about building containers or building virtual machines. As a one-man team, it's incredibly powerful because I don't have to think about DevOps. I don't have to think about operational considerations or deployment. Number 2 is focus on building code. So we saw it right at the introduction video. This is one of the biggest benefits of Azure Serverless, is that you can really just focus on building the code and not worry so much about the deployment, about the infrastructure, about building all of these surrounding aspects of your application. It's event-driven by design. And I think this is one of the trickiest parts for most people to grasp when they first touch Azure Serverless, is that it is inherently event-driven. And we'll see how this works when we walk through the code. And of course, ease of connectivity. So it's incredibly easy to build data processing pipelines using Azure Serverless because of the triggers that we can bind to our code. It's really a perfect solution for modern single-page applications. So we'll take a look at how we can use static web apps to host the front end. We'll see how we can use Azure Functions REST-based APIs to build our API for our front end. And of course, we have a fully serverless database in Cosmos DB where we don't even have to think about a schema. We can push our JSON objects directly into our database. Hands-free scalability, right? So we can scale this application hands-free. We don't have to think about how many containers do I need? How do I configure my Kubernetes scaling to handle my application and scale it up and down? With Azure Serverless, the scaling is on demand. And consumption-based pricing. So as I've built these applications, I've paid fractions of a penny to host my applications. And it's particularly interesting with Azure Cosmos DB because it takes this entire model and turns it on its head. Azure Cosmos DB is priced by, it has multiple pricing models, but the most interesting one is it's priced by what are called request units per second. That means you pay $7 a month for 400 RUs per second. Now, whatever you build, if it can fit inside of that envelope of 400 RUs per second, you pay a fixed price of $6 per month. And of course, what's really great about Azure Serverless for anyone that's coming from a .NET background or a Microsoft Stack background is there are just really familiar developer ergonomics. And we'll take a look at how this manifests when we walk through the code. So let's talk a little bit more about the connectivity, right? One of my favorite parts about working with Azure Functions is the multitude of bindings that you get out of the box to connect different parts, different types of applications, and different systems. One of my favorite ones is the Signal R binding. This binding allows you to build real-time applications without a ton of programming whatsoever. In this application, this demo, we'll take a look at how we can use blob storage, Cosmos DB bindings, HTTP bindings, and queue storage bindings to build a data processing pipeline that's going to take this data from the FDA and push it into our Cosmos DB instance. Let's take a look at our data processing pipeline. So in this application, in the COVID Cure ID application, I've built an event-driven serverless data processing pipeline that's going to take the case JSON files, case data JSON files from the FDA website, and we can move it into blob storage. And once it's in blob storage, this will trigger a function that will kick off and perform some ETL, some light ETL, and do a distribution of that case data to 2 separate queues. We'll have one outbound queue for the different regimens, and we'll have a second outbound queue for each of the drugs that are part of those regimens, so that we can view the data by drug and also by regimen. Once it's in the queues, we can use a queue trigger to trigger the different functions to perform additional transformations or additional processing and push those right into Cosmos DB. Now, as we look through this code, what you really want to take note of is that we don't have to write a lot of the underlying connectivity to get these pieces working together, okay? And if you're interested in working with the full database, you can email curesupport@nih.gov to get the full database to work with it yourself, okay? Let's dive into the code. So number one is how we fetch the data. There's a simple script, and if you'd like to see, the code is fully hosted in a GitHub repo, so you can have full access to how all of this is set up. But first is fetching the data. We have a simple JavaScript file that we can run from the command line to fetch the data from the FDA CureID website. Once we fetch the data, we use a set of Azure CLI commands to load that data. This Azure CLI commands will also create the assets in Azure. You could use technologies like ARM templates. You can use Terraform or other technologies to deploy these assets. But for me, my personal preference is to use the Azure CLI. And this simple script will configure all of the artifacts, whether it's local in your local development environment or in Azure. Now, once we have this configured, we can start to write our data pipeline. This data processing pipeline, you can see what's really interesting about it is that it's just a regular class. There's nothing special about it. I don't have to inherit from some class. I can just write a regular class. And once I've written this regular class, I can decorate it with this function attribute. This function attribute indicates to the runtime that this is a function entry point. And we have these attributes here that indicate that this is an inbound trigger from a blob storage endpoint and an outbound trigger to two separate queues, right? Now, when I start to receive information, when the first file gets dropped into blob storage, this will kick off this function. And you can see I can start processing my data right away, and there's no connection that I have to make to the queue. I simply drop my data into the output collector, and that automatically pushes it into the queue. And once it's in the queue, I can pick it up with a separate function here to process each of the entries, each of the regimen entries, using a queue trigger, listening on that queue. And once I have that information, I can do any additional transformation or processing that I need to do on my data before dropping it right into Cosmos DB. And you can see there's no connection code necessary. All of the connectivity between these different elements in the Azure Serverless ecosystem is handled by these trigger bindings. So this is an incredibly powerful, streamlined way to build data processing pipelines without having to mess with the complexity of connecting a multitude of endpoints in your code, and really cleans up your code so that you can focus on working with your data. Now, in this case, we're just doing a very simple ETL. And for that, Azure Functions is a perfect tool. It's lightweight, it's incredibly easy to work with, and you have tons of options for pipelining that data in and pushing that data out. For any sort of heavy lifting, you'll want to consider Azure Data Factory if you're doing large data streams, or if you're doing heavy-duty transformations, or you want code-free, no-code transformations. Let's take a look at how we're doing this transformation in Azure Functions. In this case, when we receive the case file, we just have a simple function here that takes the information in that JSON and starts to flatten that information down. So we're just doing a very simple JSON transformation to take a very complex JSON document and making it a very flat JSON document. Azure Functions is the perfect tool for this because we don't have to learn a multitude of tools. We don't have to configure a large system to be able to perform these types of very simple data transformations. And we can also run these data transformations locally. Now, let's talk about querying this data. Once we have it in the database, how do we get it out of the database, right? For this, we can use the repository pattern. Repository pattern is a perfect fit for the Azure Cosmos DB because it is a document-oriented database. Let's take a look at what this looks like when we have the repository pattern. In this case, this is my drug repository class, and the drug repository class simply maps to an entity type that I have in my Cosmos DB. And you can see one of the great things about working with Cosmos DB is that even though it is a document-oriented database, I can work with this database using familiar technologies, familiar paradigms like SQL. So I can query my Cosmos DB using the SQL API. I can use the MongoDB API, or depending on my workload, I could also use a graph database API called Gremlin. In this case, I have a very simple query. I can parameterize it, and I execute this query and get the results back. Now, if I'm working locally, I can also run the emulator. So Cosmos DB comes with a local emulator. You can also run the emulator in a Docker container if you're working on Mac. And this emulator allows you basically get a fully functioning Azure Cosmos DB on your local machine where you can build anything you want without paying a single cent. Now, you can see we can write very simple SQL-like queries. And in this case, we're going to find and count all of the different cases by country. And if we execute the query, we can see all of the different cases that were reported from all of the different countries around the world. What about the front end? So Azure Cosmos DB Azure Functions is not just a ETL or data processing pipeline, but it can be the foundation of building your REST APIs. And it's a great solution for building REST APIs for a number of reasons. The first reason, of course, is that you don't have to think about scaling your APIs, right? So even as your number of users increases, the Azure Functions runtime itself will handle the scaling of the API of the runtime instances for you, right? Number two is if you're like me and you build a lot of enterprise applications, Azure Functions is a great solution. If you think about your enterprise applications, they tend to have peaks and troughs during the day, right? So you'll have very high usage when people come online very early in the morning. You'll have potentially very high usage in the afternoon as people come back from lunch. Then at night, your application usage completely drops off and your servers, if you're using virtual machines, are just sitting there idle. Azure Functions is a perfect solution for building these types of enterprise applications because it automatically scales up and down with the usage of your system throughout the day. And if no one's using the application at night, it's just going to sit there and you won't be charged. In this case, you can see here, we have two HTTP endpoints that are receiving requests from the front-end static web app. And you can see what's really nice about it is that if you're already familiar with .NET Web APIs, it's really familiar to write the same applications in Azure Functions. In this case, we'll have two APIs that each map to one of the repositories and retrieves the information from Cosmos DB. Let's take a look at these. So in the data provider, once again, you can see my Azure function is just a normal class. And you can write these classes either as static classes, as you'll see in most of the online examples, but you can also write these classes as instance classes. And if you write them as instance classes, one of the benefits you get is that you can take advantage of dependency injection. So right at the beginning, at the keynote, John talked about being able to use an in-process and out-of-process model. I believe with the out-of-process model, you can use the full middleware of ASP.NET. However, if you're using in-process, you have to fall back on the dependency injection capabilities of the in-process model. And in this case, in our app startup, we can initialize our Cosmos gateway and our repositories and put it into our services container and access those as injected instances in our Azure Functions. Now, you can see the Azure function is super simple. All we have to do is decorate our function with a function name attribute and an HTTP trigger that says this function will react to an HTTP event from a client. And we can use get, we can use post semantics, we can declare the route, and within that route, we can parameterize it. And what's really great about Azure Functions is that if you're using .NET, or the Java API, you get these strongly typed parameters by default. So you don't have to guess, you don't have to process and pull this information out of the forms or out of the query string. You can just work with strongly typed data. And my personal preference is to keep the functions simple and move most of the data processing logic into domain models. So in this case, you can see we have a very simple entry point that's reacting to an HTTP event. And we simply execute the query and return the result. For anyone that's familiar with .NET Web APIs, this should look instantly familiar, right? There's nothing magical here, and that's what makes Azure Functions a great platform to build the next generation of web APIs. One of my favorite parts about working with Azure Functions is that you can build and test locally. There's no cost or commitment. You don't need to sign up for anything. You don't have to provide a credit card. You can build these types of applications completely locally using completely free tooling, whether you're on Windows, you're on a Mac, you're on Linux. You can run many of these components in Docker. And you can build using the language of your choice. So C#, obviously my favorite. But if you like F#, JavaScript, Java, PowerShell even, Python or TypeScript, you can use the language that you're comfortable with for building .NET Serverless, for building Azure Serverless applications, okay? And I also want to show you how we can take advantage of some of these developer ergonomics that we're all used to already. So for example, within this workspace, within my Visual Studio Code workspace, I can debug my application and use an F5 development experience if I want to use it that way, right? So just by clicking my start button, it will build the application, attach the debugger, and I'm ready to go. So you can see here, it's cleaning my application, it's built it, and it started the functions runtime. And now if I use my local instance, it'll step right into my debugger, and I have full access to look through my local variables and my call stack. So Azure Functions for me is a great development experience because you can work with the tools that you're already familiar with, work with the developer experience that you already have, decades of experience with, and the ergonomics just feel very familiar. Now, if you like to, you can also run this from the command line. So for example, in this case, simple as running func start, and this will also start my functions runtime. And now I'm ready to go once again with my functions running. On the left-hand side, you can see here, there's also this Azure extension that you can install with Visual Studio Code that gives you full access to see the functions that you're working on, and also access to your local storage so that you can explore the different files that you're working with. Now, earlier we talked about working with Azure Functions and why Azure Serverless is such a great solution. Of course, one of these is DevOps versus NoOps. And my favorite part about this is that working with Azure Functions and Azure Serverless, I have a really streamlined path to deploying my code right from GitHub, right? So from Visual Studio Code, I can build my GitHub actions. I can specify my GitHub actions. And from my GitHub actions, I can respond to push and pull requests and automatically deploy the code into Azure. Now, I've separated my deployment into server and API and web front end. So this means that as I'm building the application, I can separate my deployments. So I can have front end deployment separate from my back end deployment. And if I make a change to my application, all I need to do is commit and push, and this will trigger the build on the server side in GitHub and push into my Azure storage. So let's do a quick example. Let's make a small change. All set, and Now, as soon as I push this into GitHub, this will trigger an action to start building and deploying the application. And because I've separated my actions from the server side and the front end, I can deploy the two separately. I can deploy just the front end or just the back end based on which side of the application has changed. Now, what's really great about this integration is, of course, if you're using Azure Static Apps, web apps versus Azure Static Websites, right? Azure Static Web Apps pulls all of this together for you automatically. With Azure Static Websites, you have to do a little bit of the work yourself. However, I've taken the initiative and written down how you can set up this type of application yourself from the very beginning, how to build the function app itself to the different commands you need to use to pull all of this together. And one of the key parts of this is during this build process, we can inject secrets into our application that include the API endpoint that we are hitting from the front end, from the static website, our Azure credentials, and our Azure Function publish profile. We can take all of our secrets and move them out of the code and inject them at build time. So this code is made open source, and you can download it, and you can start building with it locally. Again, one of the best parts about working with Azure Serverless is that you can build in the language that you like to work with, that you're comfortable building with. You can build it in any environment that you are comfortable with, that you have access to. And there's no cost or commitment to get started and learn these technologies. And of course, the best part is that if you're already an experienced .NET developer, it's incredibly easy to make that shift from your ASP.NET web APIs that you're building today to Azure Serverless APIs that can scale, that have all the benefits of building Azure Serverless solutions. All right. So if you're interested, you have full access to the application at covidcureid.com and, of course, the GitHub repository. Any questions?
That was excellent. That was very exciting.
Thank you.
I think most of the questions were actually answered either by you in your session or in the chat already. I didn't see any new ones coming in just yet. I really enjoyed how you were saying how easy it is to integrate, and of course, how Cosmos DB is easy to use and to integrate with Cosmos DB. That's
of course one of my
favorites.
I think the best part of it is that if you already have very strong backend skills in SQL, you can take those skills and it translates very easily using the SQL API, right? If you don't want to be adventurous and start using the Gremlin API and writing graph queries, right? You can take the skills you're already familiar with and translate those into the Azure platform.
Yeah, whether that's front end or back end, as you were saying.
Whether it's front end or back end, exactly.
Yeah, I really like that.
Yeah, I really liked it also because it's a completely open source project. So I'm going to encourage people. I know Hacktoberfest is coming up, but I think this is one of those projects where you can learn from how you built the system, use it on open source data, and take that pattern and apply it to like a different problem, or maybe just contribute back to the same one.
That's definitely one of my drivers. Number one was during the spring of 2021 to find some way I could contribute to how we were handling the COVID situation, but of course also contribute this application as a pattern to the community, so that folks that are building data processing pipelines, folks that are already familiar with ASP.NET and want to build the next generation of applications on Azure Serverless in cloud, they have a fully functioning application that they can download and start building with.
So I know this is probably not relevant, but is there any kind of issues you have to deal with because this could be sensitive healthcare data?
In this particular case, the information is fully available from the FDA and from NCATS. So you can email Cure support at nih.gov to get access to the full database, and they will email it to you. You can also access the information through the website.
I love this case study. Super awesome, and I can't wait to see where it goes next.
Thank you.
Yeah, that definitely makes it an easy case study to use, because typically when people want to do something like this, it makes it difficult having access to data to get them started. So this will make it easy for everyone.
Yeah, and I can't believe, oh my goodness, we're almost at the end. We're at the last talk of the event. Are you excited?
Yes, but I think we have
one interstitial video.
One video to go. Yep.
So let's talk about it. We just heard about Cosmos DB, so let's roll tape on what Cosmos DB is.
Azure Cosmos DB helps you get more value for your money by making it easy to manage the components you pay for, database operations, and storage. The cost to perform database operations, including memory, CPU, and IOPS, is normalized and expressed as a request unit. More request units are charged for more demanding activities. For database operations, you can select one of two models, provisioned throughput or serverless consumption. Provisioned throughput is the capacity you allocate for database operations, measured in the number of request units per second and billed hourly. It works best for workloads that always have some traffic and require high-performance SLAs. If the traffic is predictable, you can use standard provisioned throughput to manually set and adjust capacity as needed. If the traffic is unpredictable, you can use auto-scale provisioned throughput to instantaneously and automatically adjust capacity between 10 and 100% of your set limit. Autoscale becomes more cost-effective than standard when traffic is unpredictable and not close to maximum capacity most of the time. Provision throughput may not suit workloads with only occasional database operations and lower performance requirements. These applications can benefit from the serverless model. While it has a higher unit cost, it's consumption-based and only charges for the request units used per database operation. With consumed storage, fees are charged for the total gigabytes used per month for both transactional and analytical storage. You also pay for storage I/O and analytical storage. Get the most value from your workloads by understanding the components you're built for in Azure Cosmos DB.
Wow, that was cool.
I really love that segment. So, Nydia, what's been your favorite session so far?
You know, I have to say, I was blown away by the keynote. So maybe I'm just kind of a little biased, but I almost thought every one of these talks was spectacular for a different reason. I was blown away by the keynote because I could get actionable information from it, right? It was like we could kind of see it being built. And I really think the use case that they had, which is how do you build an open source community set of tools and kind of use these workflows and technologies? I was looking at it going, this is just very relevant to all the things we're going to try to do because we're now in virtual event space. The second one that I personally, because I work in the mobile web space, I was like, I really like Davide's Jumpstart because I think that that's a great pattern. Labrina's game, I need to go talk to her because I kind of am very curious about how we can use analytics, game analytics to do different things. Because I think that, you know, although we're thinking about it as like large scale gaming, but I think that behavioral analytics is something that's an interesting area for us to look at. And then just because this was the last conversation that we had, the COVID data, I kind of like, we just were doing something with data science. And I find these kinds of examples are things that I think people can take and replicate, like fork the project, learn from it, play with the data, kind of build your own dashboards, if you will. So those four stuck out, but all of them, I mean, like we had a great talk from the folks from Dolby as well. I was just like tweeting all the time. How about you?
You know, it was really hard to pick one in particular, but there was this theme that went through all of them, that they were all really practical, things that we could, you know, leverage right now in our workplace, things that we could build on and move forward with, and, you know, leverage, you know, pull things out of GitHub, like little tips and tricks that we could use in our workday right now and move forward with, or be able to build upon. Or even if it was something that you hadn't worked with before, you could learn from it. You could grab something off of GitHub. You know, the Davide one with that whole end to end, you know, I was listening to that and I was like, this reminds me of years ago when we used to watch cooking shows and he would just pull something out of the oven and you had something completely baked. And I was like, oh, there's my cake. It's already baked, you know?
I know. And shout out to Prashant because I think there's low code options as well, but that sets up a big challenge for Carlos because I think he's our last speaker in the session. Hi, Carlos. How are you?
Hi, Nydia. Hi, Melody. Great to be here.
We
What a
are
cool
so happy to
presentation.
have you. So I think you're the last speaker, and you're going to talk to us about working with Azure SQL DB and serverless.
Right.
So take it away.
Thank you very much. Pleasure to be here. And what a cool performances of all. But let's start. So my name is Carlos Lopez. I'm member of the community for the data platform. I'm Microsoft MVP. So today we will talk about working with Azure SQL and serverless mode. But take into considerations, the agenda is very small, just to talk about the Azure SQL overview, the provisioning, and the considerations that we can take when we are creating on serverless, because it's a great product. It's fit for our serverless game. However, we have to be aware of the considerations, right? To win. So that video of Cosmos is just great, explaining that part as well. So checking the overview on the Microsoft Azure SQL, we can see the prerequisite for using it. You have to have the Azure account, right? The subscription. You can use it. You can manage through Portal, Azure Portal, that is. Today we'll work on Azure CLI most of the time, because I like that mode, to see the commands and not to be switching through the portal. However, we'll see it, but not that much in the portal. Using the Visual Studio Code and the great resources that are there, you can use the Azure SQL Server extension, and you can see it there, and you can use it as Azure Data Studio as well. So that's the way to manage those. And basically the cloud computing patterns that you can see in that is that you can have a periods of inactivity, and that's great for Azure Serverless, Azure SQL Serverless, that is. When you can see that compute is growing fast and unpredictable bursting, then you can change to another kind of mode that you can select. So this is the patterns that you can see in the cloud. You can see on and off. You can see growing fast, unpredictable bursting, and predictable bursting. So in that matter, that's what we have to be aware of when to choose the selected mode that we need. So it is a good consideration and concern that we need to be. So in terms of creating an Azure SQL, we have three ways to use it in a declarative mode. You have to think in the declarative model to use it. So one is the YAML file, using the YAML. The other is seeing the responses through JSON. When you're configuring through the portal, you can see it as JSON, and the responses are through JSON. And the other is using the Azure CLI commands. So whenever you are using through these interfaces, interfacing with the model, you know that the ways to use it. For example, when you're using YAML, you're preparing yourself to use, like maybe for a DevOps, you're preparing a pipeline, for example, to create all the commands to define your creation. So that's a good definition to know when to use it. So you're creating your YAML file. So when you're creating the provisioning model, we'll be using this kind of commands. We'll create the SQL server. We'll see the response for the list of SQL servers. We can see the DBs and the usage for it. And finally, we will create a database for it. So it is that simple. You just need to create the SQL server itself, and then you have to create your SQL DB for the SQL server that you have just created. That's it about it. And finally, you can delete those when you're not using it, since you only this is designed just to be used when you are when you want it. You can delete it whenever you want, just as easy. So that's a way of doing it. This is a JSON response for when you're creating your SQL server. So that's another perspective to see it. So when you're creating your SQL database, you have four models. You have serverless, you have provision it, you have hyperscale, and managed instance. That's the way that you can work in your Azure SQL environment. Today we will work about the serverless instead of managed instance. That with that you are thinking in the approach of having your SQL Server agent and all the SQL Server system databases as you know and love. However, in serverless it's different. You just have your database per se and your master database. You don't have that agent. You don't have the SQL Server agent. However, but you can automate. You can use your notebooks. You can create a notebook and automate from there. You can execute from there, and also you can use an elastic job to create it that way. So that's the good things about using the Azure serverless mode. So as we said, the way to work with the Azure serverless is to first you have to define your resource group, then you have to create the network configuration and firewall rules. You have to define a compute tier that you will use, which is the provisioned or serverless, depending on your resourcing that you need. And you have to define a SQL Elastic Pool if you need or not. That depends on. We will not use the Elastic Pool right now because we'll work on the serverless mode with a simple resource use. Also, you have to define the storage where you will create those and the compute family that you will work on. Sorry, the Gen 4 is not longer available. It's starting with Gen 5 and upper. So sorry about that. However, it's a good point to say that you can use an elastic job agent here also as a feature. However, to automate, which is cool feature, it's important to say. And it is very easy to use. You just have to separate. You just have to use the general purpose license. You just have to select the provision or serverless mode, depending on what your intentions, and to select the family or hardware family that you need. And that's all. That's all to start. So basic characteristics is that you can auto pause, you can select your service objective, you can auto scale, and you can define your service pool for the database if you want to create. So this is an important part when you are on SQL DB scenarios. For serverless, you have to identify if your server database is going to have an intermittent use, or you will have inactivity periods to save costs. So that's very important to know, because then you will be a good fit for serverless. This database is designed to scale up during time, and it is perfect when you are creating a new application database whose resources are not predictable to estimate, because you don't know yet. It is a new unfamiliar database that you are building through your development. So in that case, serverless is a great way to save costs, to know what you're expecting, to getting to know what you're expecting it for scale up. So that's good. For provisioning, it's a database with a predict long-term use. You know this database, and so you have to have predefined resources. So it is a considerably business important database. So in that case, you can use a hyperscale or business critical services depending on the service tier that you want to scale up. Think of if you are on serverless and you are going to you have this database matured in a level that you want to convert in a productive level. So that's your case. And you cannot tolerate delays on auto resume or auto put actions because there's already clients or connections there. So you're not longer thinking on developers, you're thinking on users. So in that case, you cannot tolerate delays. In that case, you need to scale up. Cannot tolerate constant memory claims, and which are the perfect fits for the serverless, because these are the consumption that allows us to save cost there. So in that case, provision is perfect for you, and the different DBs within the resource group sharing an elastic pool can be a match for you. So in that considerations, you only pay what you consume. So basically, you are working on a general purpose license. You have max memory allocation for 3 gigabytes per core. Thinking on Azure Serverless, of course, and you have 40 vCores on Max Serverless, and you may experiment a delay when you are on autopause. So basically, it's for saving cost, of course, but you have to think on that the way that it is, the architecture is thought for save cost. So basically, in terms of performance, it is important to know features that can help us. So and this is a good one. This is Azure SQL Insights, which is especially designed for Azure to monitor your database. How it works is that it uses your DMVs and collects all and transport the information to a Linux VM to start where it stores your DMV data, metadata, and collects all these time series DB in a time series DB. So basically, what you're paying there for this feature is not exactly the use of the feature. It's just that you need to have this Linux VM where you are hosting this feature. So, but it's cool because you can transport all these DMVs that that you will only have when your SQL Server agent is running. Your time series DB will collect those using this kind of feature, having this Azure Monitor agent and having all these workloads managed by this Telegraph agent that will like move this through through your monitor. So that's cool. So basically, with that, Azure SQL DB comes with great responsibility to use. So let's go to the demo to see and create a database really fast and see how it responds. Let's go here to the Visual Studio Code and see the commands that we were talking about. The first one will query out with the Azure group list, and you can query the location. You can query through the JSON describing your resources. You can see the naming here. So I have already created a resource group for the server. So here is the details for it, and tells you the resource that you use. So in terms of creation, a resource group is that easy. Just you have to dedicate the location where you want it and the resource group name. So that's easy as that, and create it just as easy as that. For the next command, you can almost easy to delete as it created. So, but it has to be told that we want to delete. Okay, so for in terms of SQL Server creation, we need to have already have a resource group, and then we will create a SQL Server. Since it is a little bit slow, I will create a new bash, and with that, I will execute the creation of 4 SQL servers. Let's see how it goes. Just in a flash. See if it takes a little bit of time. Oh, resource group list. Oh, already, because I I delete those. Okay. Sorry about that. I didn't see the delete. Okay, no worries. It responds a little bit slower, but surely I know it's my mistake. Let's change it to 1. Just as easy as that, you're creating 4 SQL servers, and then it responded real fast, the first one. And when it's cooking, we can see another kind of usage of that. We can another operation that we can do is copy the database. So since it is still running the creation, we'll create another bash, and we will copy one of the we already have. In this case, we'll copy a database for the resource group, the name of the database that we have, the server that we have, and the database that we are trying to move, and the destination to move it through. Let's see. Just as simple as that. Oh, sorry. Sierra was not on the details. I wonder if I already killed that. So sorry for that. Still completing the SQL Server creation. So we'll move to another example. Still not seeing why it's not finding. I think that it is because the name is different. That is why you don't have to change your code in the middle of the test. Okay, let's try to create a SQL database now that we have tested the creation of a SQL Server. Just as easy as that. We just select the family that we want, the minimum capacity, the compute model, which is serverless. We'll set the auto pause to delay to 60 minutes, service objective to be basic, storage redundancy to be local, and the collation for a database we'll set to CP1 CIAS. So with that, we'll execute, and with that, we'll create a SQL database for the server. We have more examples, as you see. Think of this example is just to figure out if you want to create tons of database and automate. So in that case, you need a way to do it. So see, Azure CLI is just good for that, creating databases, just as simple as that. And this is the example. So let's move to, now that we have seen how to provision using the Azure CLI, let's move to see the Azure SQL, to move to the connection to the database. So with that, we can use the SQL Server connections, declare configure the resource that we already had, and set the test. So right now I'll move to my demo over here. And as well as we do it on SQL Server on-prem, we can see the DMBs. We can see this is just an example that we can see the same DMBs that we can see on SQL Server. I'm sorry, it was on other view. So this test is just to show you that you can query to see the DMVs there. You can see the results that the memory clerks use, the objects, the object locks. You can see the virtual use and the memories, as well as we always do. We can see the resources using the same DMVs that we always have used in the past. Resource stats, sorry, I read to. You can see the average and maximums, the logical writes, memory utilization, the weights of the database. We can see the performance, the max job operations that already comes configured in the SQL Server. Right? So what we're seeing here is the total wake times. We can see the parameters for the database that's already configured. We can see the plans. If we are DBAs, we are always thinking of these kind of features, how to look at things. And the other way is how to create databases in T-SQL mode. You can do it. So for that, I created a script just to tell that we can execute this command as T-SQL as always, and we'll create just as that we'll create a database for itself in Azure SQL mode. You can see the SLOs. Change the service objective if you're trying to move, switch up and scale up. You're trying to upgrade your database. So basically, that's what you can do. You can alter it through command. Change it to service objective. I have put it a little bit of code here to show if you're on standard, you can move to premium and select which one you want to select. So maybe you can put here another value like S1 or S2. And with that, oh, sorry. Your request. Oh, okay. Let me change it to 0. Like it lost connection, I think. See the elastic pool here. The database itself. You can see the general purpose edition. We can see the service objective and the SLO that is already working on here. So basically, this is the kind of operations that you can do when you alter your database through your T-SQL command, connecting to a Azure SQL database and switching to another. So that's another way to do it. If you are connecting through the engine database. So let's take a look around how it's looking in the SQL Server databases that we created here. So let's refresh here. See if it created new ones already. Takes a little bit of time. Yeah, it already created 99. We can see the databases that as well as we can see the SQL. Let's see the resource groups. CR01. So basically, it had created 4 SQL servers and 2 databases in all that we have done, basically with simple commands in Azure CLI and T-SQL. So this is cool to another way to handle SQL Server instead of Management Studio, which is the traditional way to manage. This is more centralized for me to handle, so it is good. I don't know how are we going with time. We already
I think we're going to kind of be wrapping pretty shortly, but I do remember you told me you taped this talk, the talk before, so I'm hoping we can share the link with people, and this has been super interesting. There are some questions. Would you be able to go on the chat and answer them, Carlos?
Sure, of course, I'll be on the chat.
Awesome. Thank you so much. I think we will be dropping very soon. So Melody, before we kind of wrap, I think huge thanks to all our speakers and to our audiences from all over. But I guess we have a few calls to action.
Absolutely. We want to make sure that you check out all those great sessions. They'll be on demand, and you can check them out at the homepage or aka.ms/Azure Serverless Conf. That'll be put in the chat for you to click on. Or you can learn more about the skills challenge and compete to get your name on the leaderboard. Visit the homepage or aka.ms/Azure Serverless Conf/challenge. Also, you can also go back to our homepage and catch our next stream for the Asia time zone this evening, or get up early tomorrow morning and watch the European stream, or you can watch the live stream on demand.
That's right, 20 hours of this. This is going to be awesome. So don't forget to go bookmark those sites, and we hope you got a lot out of this. Share your comments with us on Azure Serverless Conf, and thank you so much.
Thanks for joining us. Hope to see you again all next year.